useful information. But for research purposes, it's more complicated. So we have like a team of experts really that can speak to patients and tell them about the risks of the procedures themselves, and the relative benefits, which are not directly to them, it's more benefits to science. We have a lot of expertise in doing that and have been very successful. But yeah, it's a big part of what we do is like be able to recruit research subjects that are appropriate and characterize them.
Thank you. So we will proceed. I'm going to be introducing Mrs. Naila Bafli, who is representing Ms. Tuba Islam. So Naila is an analytics expert in SAS, UK. She designs analytical solutions to solve complex business issues in creative and effective ways. She's specialized in predictive modeling, segmentation, text mining, forecasting, and analytical life cycle management. So Naila has implemented many successful projects across different industries, and she has been now at an SAS partner for almost 10 years. She has an engineering background and holds a master's degree in statistics. Welcome.
Hello, everybody. It's an honor to be here. And great people, great food, everything is great. Thank you for inviting me. And okay, so I'm the substitute speaker for Ms. Tuba Islam. And I've been working in this domain for more than 10 years. I've completed many projects, of course, using SAS. And I have my, I studied engineering, then I studied statistics. And as a student, I started using SAS. And then still now I'm using SAS because SAS is everywhere. Wherever you go, you will see big major companies using SAS. SAS is in more than almost 150 countries, used in more than 80,000 sites, and it will be growing. So I urge all the students to learn, I encourage them to learn how to use SAS. And one of the reasons why SAS is that popular and it's used in every sector and every big bank, financial institutions, retail, or telecommunications operators, is that SAS is reinvesting 25% on research and development, whereas industry averages merely half. So let me go through my schedule. First, I will start with the commonality of use cases in unconventional sectors. And then I will mention about the ingredients of success and the challenges of them, and then real-life examples on healthcare. So, power of analytics. So, data scientist is the most wanted job in 2016 in the USA. Everyone wants to be a data scientist. Everyone is talking about big data, machine learning, cognitive computing, and that stuff. You know, that's in everybody's mouth. So, and recently I've come across in one of the web pages that professional networking web pages says that I'm supposed to know this person who is entitled a data scientist. And I know this guy from previous project, and I know what he's doing. And he wasn't a data scientist, as far as I know. And I called my friend. You know, did you start hiring data scientists? And she said no, and why is this guy is a data scientist all of a sudden, they implemented SaaS. They bought SaaS, and now they are using SaaS, and now everyone in the department suddenly become a data scientist. So, and she tells me about that. They want to do the machine learning. They want to do machine learning. They want to take away churn prediction from the CRM department. So what's this guy doing? And she goes like, this guy is actually reporting the number of cash loans that has been sold by that bank daily basis. So, this is data science, so everyone is trying to take a bite of it. And there aren't many women, let me tell you. When I go to the projects, I'm almost always one of the few women in the whole floor, or in the project, or in the department. And actually, just recently, 2 days ago, in one of the biggest banks in Turkey, I had to sit with a SAS administrator to figure out what should be the best buffer size, memory size, and source size to read the 600 million of data. I'm telling you, I was the only one, apart from the secretary. Okay, so there should be more women. I encourage all the women, all these clever women, girls, students, to go into this field, because this field really needs you. So why now? Why suddenly everyone is talking about big data, machine learning? Because I think there is more data primarily, but there is now we can store more data on a cheaper rate, right? And the CPUs are faster, and they are cheaper, and there are more improvements, there are more research on more clever algorithms. So these all three incubate development of clever and more developed models. So let me go. These are just the regular conventional selection of use cases. What we do churn prediction, we do credit analysis, credit scoring, customer lifetime value, customer segmentation, and social network analysis, market basket analysis. These are just what we are doing so far. But I'm saying that we can just use the same process. We can keep the process, but we can move this to different unconventional sectors, such as healthcare. So it's the same process with different actors and we will be telling a different story. So in the customer view, we would be having profit-based customer segmentation, and in healthcare, in the patient view, we would be having cost-based patient segmentation. Instead of credit risk, we would be having risk of readmission, risk of patient is coming again to the hospital. And instead of having customer journey, we would be having patient journey. So what are the ingredients of a successful data science project? What should we do? So everything starts with data. Without the relevant data, accurate data, and accessible data, we cannot do anything. So on the basis, we should have a good data. These are the 3 Ds, by the way, 3 Ds of a successful project. And then we should have the enough expertise, and skill set, relevant skill set to play with this data and figure out a model and take out the valuable information from this data. And then we need to deploy it, right? We cannot just say, here is your, dear colleagues, here is your model, and we're just going. No, you cannot do that. You have to deploy it. You have to make sure that's automated. It's been run periodically, depending on the project, and you should be monitoring it. Because without the monitor, you cannot make sure that it's stable. You cannot sure. For example, Trump has become president of the United States, and the markets are very changing now. Everything is very volatile, and you have to adjust. You have to adjust your model to go to run stable through the time. So, and these were the 3Ds, and I'm telling you about the hidden and secret 3Cs. So this is creativity, collaboration, and communication. So women, aren't we best in these 3Cs? I know that in every project, if there is a woman, that project goes very smoother, faster, because women talk, women collaborate, women are one step ahead in creativity. So please, women, go into this field. So what are the challenges? These are the common challenges on each industry, in each sector. So the good quality of the data is the biggest impact on your success. And by experience, I can tell you that 70% of a model implementation or creation goes into preparation of the data. So all these IT people are preparing data for you. You should thank them, because then SAS does everything for you. So first, you need to have good IT people to prepare your data. And then you should interpret it. You should tell your project, your model, whatever you are modeling, in a very easy way. So everybody should understand what you are talking about. You cannot say, this is the black box, okay, management, this is the black box, I'm giving you, please use it, please run it regularly. You cannot say that. You have to explain this black box to the users. And then you need to deploy it, you need to implement it to the system. And then you need to check the stability. You need, for example, in credit risk, you need to, after you implement your model, you have to go there and say, or automatize it, say, this is the score stability across the periods. This is the characteristics used in the model, and this is the stability score for these variables. So healthcare is a different story. It's so much harder because it's a new subject and there isn't structured data available. And data sources are very disparate, and there is no unique index for patient, let's say. And as you might, medicine people would know, there is these ICD codes that has been built by World Health Organization, international classification codes. There are almost 15,000 of them, and they are very valuable. You are supposed to use them, and how? SAS has solutions for all of them, so relax. And so this is the image of how disparate, how different your data sources can be in healthcare. So in one dimension, you have description, demographics, descriptive dimensions, demographics of your patient, utilization and cost, whatever he's paying or he or she's paying, the segment he or she is at. And there's treatment dimensions, number of treatments, number of episodes, types of episodes, and prescriptions, whatever drugs he or she used, and the operations he or she went through. And there's another dimension, which is instead of having customer experience, we have here patient experience. It can be feedback letters, surveys that has been done on patient, and if there is available, of course, net promoter score. So it's really hard to combine all this data in a healthcare project. So this is a real life example that has been done for NHS in UK. in the UK, and this is a presentation of how we can use SAS to enrich our data. I just mentioned about the ICD codes. There are many of them, and they are very important. You are supposed to use them, and how? Imagine for each patient, for one patient, you have 200 ICD codes, ICDs, right? And for another customer, you have 200 more. So in order to take out information and put it in the SAS miner, you're supposed to take the flags of it, create derived variables from it, and then suddenly, if you want to create flags of it, now for 200 and 200, 400 new variables are there. So once you transpose the data, now you have 400 variables. So it's not manageable, but thank God we have a SAS text miner. So once you load your data in SAS text miner, you can do various things. One of them was concatenate these texts, these codes into one topic. These are called topics. And just like you do principal component analysis on variables, you are doing, you are trying to combine these most important and most valuable topics or ICD codes. You're just creating new variables using this codes, and then you can take out, let's say, top 20 topics. I'm going to use top 20 topics, top 50 topics. So life is so much easier. There is an example of codes that I've been talking about. So it's very detailed, as you can see. And so, for example, for each topic, you can see there are many of ICD codes inside. And there's another real-life example. This is the unsupervised and semi-supervised methods for patient segmentation, and then after that, profiling for it using decision tree. So, as I mentioned, this is the prepare the data. Modeling is very hard. First, you prepare the data, and then you do a cluster analysis to create your segments. This is called unsupervised modeling. Once you determine, once you know your clusters, let me show you an example. So at this point, we know our cluster. So this cluster has been selected. So you see the purple, you see the brown segment and the purple segment on the right-hand side. So you see the purple segment. There is no utility. There is no cost. It's an idle segment. Whereas on the right-hand side, you see purple segment. These are high-cost patients, and they are coming to the hospital unplanned. So let me go back to the diagram. This is the basic diagram of a SAS miner, by the way. So after then we are in the target definition phase. Once we know our segments, we go back and dig details from this purple segment. Why is this purple segment like this? Why is that they're using the hospital that much? What can we do to know more about these patients? So this is just the basic methodology for a mining project. So we set a target. Now in this project, our target is purple segment. So purple segment patients are flagged, and there is this set roles part. This is the metadata the lady was talking about. This is the data of the data where you set what your variables are, and then you take the small sample from it because you don't have to use the whole data to figure out what's going on with your data. Then you do the data partition, so you can have your modeling data, then you can have your validation data, and then you can have a small data to test test your model. And after that point, we just do grow a little tree. Here, the focus is just the purple segment customers. And at the back leaf, at the bottom leaf, you see that almost 75% of the patients are dropped in this leaf. So once we click on it, and we can see the English rule behind it. And then we see that there is an association between cardiac and gastro visits. So, and that rule has been given to the management, saying that, you know, these purple customers are coming because they are coming a lot to cardiac department and the gastro department. Maybe you know, these medicine people know what's behind it, but that data is already saying that. So, and there's another real life example. This was an audit project done in Denmark. So previously, doctors were filling out the reports, right? So most of them, they are empty because they don't have time. I'm sorry. They don't have time, or maybe they're just forgetting to fill some fields. So by the audit department of this hospital, only 1% of these reports were taking, and then trying to fill these empty blanks, empty fields. So, but it was time consuming. For each patient, for each report, it was taking 10 minutes. So by using SAS text miner, these fields are filled with a very clever algorithm, and the management was really happy about it. So this is just an example of it. So I mean, we don't have to use SAS just for these sectors. There's I don't know if you know that there is a Data for Good initiative. SAS is part of it, and World Wildlife Fund has been using SAS to predict the donors that will be giving most donors and to this initiative. And there is another one which is very important for us, teaching coding to women in Ghana is part of this initiative and part of SAS too. So that's about it. Thank you for listening. If you have any questions, I can take.
Thank you very much. I'm sure that many young women here have been inspired by your presence and will be seriously considering going into this data analysis world. We have time for one very brief question. Otherwise, we can proceed with the next speaker. Okay, so we'll move on.
There is one gentleman.
Yes?
I couldn't hear, I'm sorry.
If one sees job descriptions for data science online, most of the time they ask for Python and R.
Yes.
Because now, you know, the state-of-the-art libraries mostly are written in Python by leaders like Google. What's the advantage of using SAS here? What's the difference, and
yes.
does it bring any advantage?
I mean, in the sector, you will see that every major company, every big bank, financial institution is using SAS as their primary statistical software. As I mentioned, it's over 100 countries, more than 80 Ks. You can learn Python too. I know Python, but I mean, you cannot go to a bank and set up, you cannot use Python very easily. It's not set up. So SAS is everywhere. If as a student, if you learn SAS, you will be very lucky. I mean, you will be selected very easily by these big companies. Yeah,
but most of them are using Python at this moment, no? Am I wrong?
Actually, there's
not banks. I mean, just like regular, anything but
Yeah,
buns.
I mean, that is true. I know Python too, and I love coding Python. And SAS is actually using Python behind the text mining. So behind the text mining product. Python is good too, but SAS is more, how do I say? Widespread, yeah. Yeah, and more user-friendly, actually. I mean, only coders can code Python, but SAS has a user interface, which is like, as I mentioned previously, that gentleman who is just doing the reporting is using SAS without knowing any coding. He's just, using the interface. And so it's user-friendly.
Okay, I see. And can it support like massive data sets?
Actually, in my just 2 days ago, we've been dealing with 600 million of observations in transactional format, transactional data, and it has no problem. Yeah, it's very. I mean, it's depending on the server, of course, depending on the machine, and SAS can alter these without problem, definitely.
Okay, thank you.
Thank you. Okay.
Thank you. We will have a few minutes after the session to ask questions for all 4 speakers just before the break. So Dr. Farah Najah is an associate professor in the Nutrition and Food Science Department at American University of Beirut. She has delved into several research projects, mainly concerning obesity, diets, and NCDs. She has also received several awards, including the Constantine and Constantine Rebey's Best Paper Award for 2011 and 13, and Best Poster Award during the first annual Biomedical Research Day at AUB in 2012. Welcome, Dr.
I hate to be the speaker that's standing between you and your lunch, so I'm gonna keep it very, very brief and try to wrap up very quickly. I'm gonna be talking to you about dietary intake data, something quite different from what you've been hearing since morning. I'm gonna present the good, the bad, and the ugly about our data. So first, I'd like to explain what is dietary data, what do we use it for, what are the traditional approach, the old approaches that many are still existing in studying this kind of data, what are the novel approaches, and I'm gonna spend some time describing what our team at the in our unit, in our research unit, are doing in tackling a novel way to look at dietary data intake. I'm gonna zoom into Lebanon big time, so you're gonna be hearing from me Lebanese in Lebanon quite frequently today. So first, as the name depicts, what is dietary data intake? It's what do we eat. As simple as it sounds, as hard as it is for us to get as researchers. It's very hard to characterize somebody's diet. If I ask anyone, what have you eaten, it will be an impossible mission for them to crack it down to the nutrient level. So we collect dietary data at the national level, meaning in Lebanon, let's say, how much do we produce fruits, how much do we export, do we store, do we waste, and then we divide equally on the population. Of course, this has a big drawback because we don't all eat the same. At the household level, same. We collect data about how much the household buys, stores, wastes, and we divide over the number of people in the household. And again, this has the same problem that not everyone in the same household eat the same amount of food. And then we collect data at the individual level. We ask the person, what have you eaten? And we track it down to the individual level. And this is where most of our work is. Now, why do we get the dietary data intake? The main reason why we collect data, dietary data intake, is to link it to disease. We want to know what is that food item, nutrient, food pattern that decreases the risk of cancer, cardiovascular, diabetes, hypertension. So that's the main aim. Once we know that, the next level will be we want to know who is eating what, because we want to intervene. So are the poor eating more processed food? Are the rich eating more fruits and vegetables. We want to intervene and we want to define who is eating what to be able to develop efficient interventions. So now that we have understood somehow what are our dietary data intake and what are they used for, next let me tell you what are the traditional approaches, the limitations of the traditional approach to study dietary data intake. Most of the researchers working, or quite a few of the researchers working on dietary data intake, they look at a single nutrient. So beta-carotene, vitamin C, is it good, is it bad? Fat, is it good, is it bad? And so on. So either we look at a single nutrient, at a single food. You would see researchers building their whole careers around pomegranate or garlic and their health effects. Or a food group for fruits and vegetables. Again, they would focus on that particular food and try to link it to disease and health. However, we never have a plate of vitamin C on its own. Like when you want to go out now to your lunch, you're not going to say, please put me some vitamin C, sprinkle some vitamin E, and quite a bit of protein, amino acid, this one and that one. We never do that. We eat meals. We do not eat nutrients. Because these nutrients do interact with each other. So if we eat vitamin C and vitamin E, what happens? If we eat fat and a certain antioxidants, what happens? Do they stay each one on the side in our stomach and they get metabolized differently? No, they do interact with each other, either producing a symbiotic, synergistic effect. And there is some kind of philosophical drawback to that particular approach. If you eat a certain food de facto, you are missing on the other one. We are made to eat a set amount of food. So if I am eating a lot of fruits and vegetables, de facto I am missing other foods. So is the health effect based on the food I'm eating or on the food that I'm not eating? For the statistics savvy among you, and obviously listening to the previous speaker, there are quite a few here, we've got the problem of collinearity. When you plug in so many variables in a model, many of them are collinear. A food that is high in fiber is high most of the time in vitamin C. How can we tease the effect of each one apart? So you have that problem of a large amount of variables that you want to see their effect, but they're collinear, they're correlated. Just to give you, these are the nutrients in a food. If I was to plug these nutrients into a model, chance alone, I'm going to get some of those significant. The number of nutrients we're dealing with in a certain food is just humongous, and it's by mere chance we're going to get some of them statistically significant. So what did these limitations lead to? Our supplementation studies failed. Whether we like it, we don't like it, we have failed in supplementation studies. Take that, beta-carotene, and this is the very famous study of beta-carotene, which increased mortality. We love beta-carotene. Beautiful antioxidants, beautiful mechanisms. Give it, increases mortality. Fat, we almost adored the story of fat, increasing breast cancer, and so on. The Women's Health Study, no association. Calcium and osteoporosis, that's our motto. Eat calcium, vitamin T, protects from osteoporosis. No association. So our first supplementation trials told us that it's not a one-man show. It's not that particular nutrient on its own. And this is on the scientific level. Now take a look at the Time magazine back in 1984. Cholesterol is bad. Cholesterol is killing you. Next, 1999, same, Time magazine. Low carbs diet are the best. Low carbs diet are high in cholesterol. Fine. Take a look. July 2014, eat butter. If we scientists are confused, let alone the general public, so that this situation led to a big confusion and frustration among healthcare professionals as well as among the consumers themselves. The way to go, either we go back to our labs, design another study, try to nail the fat story, and make more and more studies of single nutrients and trying to understand their effects, or for God's sake, come up with a new idea of looking at this data set. Just think outside the box. It's not a one bullet. It's not a one-man show. What is it then? So here I'm tossing in the dietary patterns approach, which is looking at a whole diet rather than a single bullet. Rather than a single nutrient, look at the whole diet. Instead of me looking at 150 food item, 160, 3,000, 30,000 nutrient, forget them, put them behind you, and look at a dietary pattern, نمط غذائي, or a dietary pattern. I'm gonna go do some very simple math and simple depiction of the principal component analysis that we have used in order to derive our patterns. Take our subject 1, shown on the slide. That subject will be eating chocolate, vegetables, bread, ice cream, and whatnot. This is like many food items this particular subject is consuming. In the traditional approach, I'll be projecting that subject on all these vectors and trying to understand which food increases, decreases the risk of disease. In the new approach, I look closer at these food items. What are the foods that are moving together? Well, I can see that pizzas, burgers, chocolate, ice cream, French fries are moving together. And instead of looking at all of these foods, I look at one factor, which is I call based on the food that make this factor, and probably this is a Western type of diet. I look at vegetables, fruits, burghul, breads, olive oil, and then moving together is these variables. Instead of looking at all of them, I'm gonna look at one factor, and because of the foods making it, I'm gonna call it the Lebanese pattern. So now my subject 1, instead of me being confused with a gazillion foods that this one person is eating and a gazillion nutrients, forget them. I'm gonna look at 2 patterns or 2 dietary intake patterns, and I'm gonna project that intake on 2 patterns rather than the whole. We have picked up this novel approach in our unit, and we have decided to go forward. In 2011, we have looked at patterns and obesity among adults. We have looked at type 2 diabetes, metabolic syndrome among adults, multiple sclerosis. We have done a few reviews. We have looked at obesity among adolescents and dietary patterns. We have looked at the oropharyngeal cancer with our colleagues from Syria. We have looked at adequacy among elderly. And we have looked at dietary patterns among and its association with metabolic health among obese. From all these studies, the population is eating 2 main patterns, the Western and the Lebanese, as I have said before, and these are the foods that characterize them. The Western fast food, meat and poultry, sweets and sugar-sweetened beverages, butter and mayonnaise. Traditional Lebanese diet, and these are the foods making it, with more fruits, vegetables, legumes, olive oil, whole dairy, eggs, grains, nuts and seeds, and traditional sweets. So we have depicted these 2 patterns. Next, what are their health effects? Association of these patterns with the health effect. On the y-axis, you will have the odds of the abnormality. On the x-axis, you have the adherence to the pattern. So the more we go to the left, the more we adhere to the pattern. You can see that only adherence to the Western increases hyperglycemia. Lebanese doesn't do anything. Only the Western increases obesity among adolescents. Lebanese doesn't do anything again. Only the Western increases the odds of cancer, for oropharyngeal cancer. Only the Western increases the risk of metabolic syndrome, and our Lebanese is not harmful. So as a summary of these results, you can look at that slide and you can say our diet compared to the Western is a good diet. The Western is the one increasing the odds of the diseases. And if you look a bit closer to that slide with dim lights, or just try to shut down your eyes a little bit, you can see our map. Where are we on the map? And you can see the Mediterranean behind us, behind the map of Lebanon. So we have done this exercise, and we're like, maybe our diet is a Mediterranean diet. Now, for those of you who are in the field of nutrition would know that the Mediterranean diet is a huge concept that has been dealt with over and over in the literature. So we looked at the literature and we've seen no consistent definition of what is a Mediterranean diet. And the only definition that we were able to see is that it's that diet that dominates olive tree growing land around the Mediterranean basin. And we have found evidence compelling that Mediterranean diet is protective from many diseases. So when we looked at the map again, definition of Mediterranean diet comes from Greece, Italy, southern France, and Spain. Really nothing was coming from the east side of the Mediterranean basin. Though we're Mediterranean, but no index was tossed in. No diet from any of those countries was tossed in as a Mediterranean diet. So here comes our study. We wanted to present the Lebanese diet as a variant of the Mediterranean diet, but this time from the east side of the Mediterranean basin. We have done this study. Now, if you tell me what to eat, we have developed an index to operationalize our diet. Tell me what to eat, I will tell you how Lebanese you are. So, only in relation to food intake. So, I can give you a score over 27 because the Lebanese diet is made up of 9 food groups. We divided them into tertile. If you eat more of that food, you take a 3. If you eat less, you take a 2 and then a 1 to a maximum of 27, a minimum of 9. And that index now can assess how adherent you are to your diet, to your Lebanese diet. We wanted to compare that diet with the already available indices. Like, are we in line with the others? Yes, we are. Our diet really correlates nicely with all the other indices tossed in. And in this slide, I show the correlation, the Pearson correlation coefficients between our index and the indices proposed by France, Italy, Greece, and the EPIC Europe. The highest was found with Italy. So we were very, very happy to bring the definition to the east side of the Mediterranean, proposing our own diet as a Lebanese Mediterranean diet. What does that mean? With that proposition, by proposing that diet as a Mediterranean diet, we encourage the consumption of local food, we slow the nutrition transition that we're having, we decrease the risk of obesity and other non-communicable diseases, less cost. Our Lebanese diet is not that costly. At the national level, we expose our heritage, we increase tourism and agriculture, and we encourage the local food production. Next. So what was our next step? Now, we're very happy. Our Lebanese diet is published in the European Journal of Nutrition as a Mediterranean diet. The next question was, is it sustainable? You know, in the light of the recent sustainable development goals that were tossed in, is our diet sustainable? If I recommend the consumption of these 9 food groups, is it good for the planet? Is it good for Earth? Is it good for greenhouse gases? Is it good for the water, for the seawater, for the forestry? Will it end hunger? So our next step was to calculate or to devise metrics to see whether the diet that we're proposing is healthy for us, but also healthy for our ecosystem. I'd like to acknowledge all the team I'm part of, which is headed by our own Dean, Dean Nahla Hwala, and with our colleagues. I want to thank all the collaborators from all the countries, from Syria, from Iran, and I'd like to acknowledge the National Center for Research and the WHO for funding us. Thank you.
Thank you very much. This was a wonderful presentation. Before lunch, we can eat
Yeah,
peacefully.
you can eat your I hope
Right.
there is Lebanese food out there.
Definitely. So I'd like to invite all the speakers for just 10 minutes Q&A session.
I didn't see any part.
Can I start with the first question? So it's a question directed for both of you. My question is, what is the limitation today of data collection in the medical field. And do you have enough population diversity that you study? And if so, do you see any differences in terms of clinical presentation and response to treatment?
I can take a quick stab. I think that one of the major limitations is always funding, at least in terms of research. That's, I don't know if you probably experienced some of it here. I mean, what's the impediment to data collection? Usually it's the cost. Having access to diverse population, that's another limitation. But to me, cost is cost and funding.
Yeah, I think always our issue is funding is always difficult. But if you, in relationship to diversity, I think there are a lot of preconceived prejudices, especially in some populations. For example, populations that have had in the past experimentation done on them without consent, they're very afraid and weary of being considered for clinical trials. And what I think the one single way, so we advance medicine by bench basic discovery, then the next and critical step is to implement this basic bench discovery to the clinic. And that involves clinical trials. And clinical trials are very, very critical, but they are very difficult. Big part of it is the funding. They're very expensive to do. But also there is a lot of ethical issues around them and a lot of regulation, rightfully so, because you don't want to do anything wrong, do no harm to your patients. So that's already difficult to do, and people are reluctant to participate because it's difficult to get them to do. But as I said earlier, these centers for translational sciences now through NIH, the goal is every single patient be participating in a clinical trial at some level so that we can advance our outcomes knowledge. So I think I think a major challenge is to convince people that clinical trials will help them, not hurt them, and that your intent is to do no harm. But there's a lot of fear about that.
I have a question for our last speaker.
Yeah, the diet.
Yeah. I have a question for you. Thank you. It was an amazing talk. So, in the Western versus Mediterranean diet, were you able to control for factors? Maybe the people who like burgers also smoke a lot, or drink a lot, or don't exercise. I mean, if you eat a burger, you're unlikely to be exercising.
That's a good statement.
So,
all right.
address this.
The associations that we have seen are from multiple regressions whereby all these factors are controlled for. That said, your point is extremely timely, because we are moving from dietary pattern to lifestyle patterns, and I've done that on a Qatari data, that we have defined a lifestyle pattern rather than a dietary pattern alone, because diet alone cannot stand. It's smoking, it's physical activity, and we were able to see exactly what you're saying. Smoking has come together with the Western, has come together with sedentarity, and this is where the effect was humongous. And we have looked at the metabolic syndrome and hypertension among women, among Qatari women of childbearing age.
So this is really interesting, because you're saying in a way, stop going after this one single factor that's going to explain one disease, and just look at the global picture. And the more global you are, the more relevant it's going to be.
I will not discount the single nutrient.
Yeah.
They complement each other. We always have to have the single nutrient research, but it's got to be complemented with the big picture as well. I'm not discounting that. My colleague next door works on phosphorus all his life. He's gonna kill me if I say so. So no, they complement each other, but we've got not to forget the big picture.
I have a small question. Sorry. You mentioned the brain and neuroimaging changes. At what age do you start seeing these changes related to Alzheimer's? And are they related to lifestyle? Did you find any correlation?
So I personally don't study Alzheimer. I study schizophrenia, but I can answer your question from the point of view of the brain in general. There are many things happening throughout development. So the earlier you can image in general, the better off you are. So for example, for schizophrenia, we know now there's something going on starting in utero, that these brains either had, vulnerability factors related to their particular genome or to particular toxic environmental insults that happen in utero or right around birth. And there is a malfunction in the development of the brain in multiple ways that kind of just comes together at a critical point during adolescence, early adulthood, where the symptoms start to show. But things have been brewing earlier. And people now start to look at before onset of the disease. We call this the prodrome. There are just fine signs of dysfunction, but not yet criteria to meet the diagnosis. And that is the case also like for autism and other developmental disorders. So the kind of the development of the brain early on is very important. In terms of the later onset diseases like Parkinson or Huntington disease or Alzheimer, it's later in life that you can see things. For example, Huntington is an interesting one because they discovered what is the genetic mutation that causes Huntington. But it's like almost like a dose of that is going to determine how early the disease will show. And it affects the brain, our findings in the brain, they're trying to understand. So going from the gene to like what happens in the brain is a huge line. It's not even a line, it's a world to try to understand these. So yeah, it's important to track down how soon, how early, and sometimes we can't even go early enough. There are also limitations on using radioactivity for research in children. So some of the PET methodology cannot be used really in children, but some of the MRI can.
Thank you all for the time you've taken to present your papers. But actually my question is addressed for Dean Lina Abed. I noticed that your research involves, metabolites and proteomics and the study of proteins and DNA. And as many of us know here, the human DNA is probably one of the biggest databases and it has a huge ability to store data. But my question is how long such a study usually takes, and the sort of limitations that you face with analyzing this data in terms of software and hardware and the ability to make assumptions based on the data that you collect. And where do you see artificial intelligence being involved, especially with Watson, being able to analyze unorganized data and do data matching from different sources and make assumptions automatically? So where do you see data scientists, as many of the people attending here, what their role is in the future? So yeah, I'd like to know.
So yeah, that's a very good question and a tough one, but I think there are many resources. It's not my primary area, but I know quite a bit about it because of my other parts that I do. So there are places like the Broad Center, the New York Genome Center, and they all have really good websites and they're very informative. But basically, these places, and there are others all around the world, where they sequence genomic material, and they can do based on human sequencing, or they sometimes do based on animal data. But basically, in many places, for example, in the New York Genome Center, they have very large capabilities to sequence many bases of many samples from many people at the same time. And they get all these data, and then the data are stored, and they have fantastic bioinformatic teams that study these data and ask these questions that you're interested in. One example, for example, the New York Genome did recently is take brain cancers, many patients with brain cancers, and sequence their human genome and sequence their tumors. So there's approaches. You can either sequence the brain, the tumor itself, or you can sequence the whole patient and try to see what hotspots you find, what mutations you find. And some are known, some are unknown. There is, in the New York Genome Center, I know a bit more about it because it's in the state of New York, it's actually in New York City. They have the Watson computer that actually they collaborate with, and they study. So they have known things that are already known to be mutated in cancer. So what they do is they get all this data from many sources, and then they look at mutations. They look for mutations, and then they try to figure out which are actionable mutations, like which mutations are not just existing but actually have a function. And all of that is done bioinformatically, and they have huge computers and sources and places to store their data. But it's fancy technology, and it's happening faster than we can handle. And artificial intelligence clearly has a role because you have to look for the signal in the noise. That's becoming, very important. But for you to be able to use artificial intelligence, you need a lot of data. So it's not enough to have 100 patients or 1,000 patients. You need tens of thousands, and then you can begin to say, okay, in lung cancers, you can see this signal from this noise, and hopefully be able to reduce it. So there's, there are a lot of challenges, but we're really evolving, and I think data scientists like bioinformaticians, mathematicians coming together with physicians is crucial, and that's one of the main areas. But not only physicians, biochemists, molecular biologists, people coming together, including people who understand metabolism. Because in many cases also, we have the genome, which we don't find anything wrong in it, but we can look at the proteome and find a protein's altered. It's degraded in a strange way because of what's called a post-translational modification. Or we can find a metabolite that's altered that can cause cancer. Where is the genome? So you need all these, and then now there are really nice programs where you can get the data from a genome, a proteome, and a metabolome from a single patient, and then try to see what's weird there or what's different, and then compare that across patients. And so there's more and more data to be analyzed bioinformatically.
Thank you.
Hello, thank you for the presentations. My name is Joanna Naufal. I'm a breastfeeding consultant. I have a question for Dr. Najah. Now it's very trendy to do a DNA testing for, if you go to visit a dietitian, and then you can analyze the type of diet that's more convenient for you. So how much do you think this is true? And do you think that, if I offer a Mediterranean diet for an American, would he be able to metabolize olive oil, other components of it? And would, in this case, DNA testing be essential?
That's a tough question. That's taking us to precision nutrition and the nutrigenomics field, which is quite blooming right now. I can answer it from the perspective from studies that have been conducted in the States, and that showed clearly that adherence to a Mediterranean type of diet has decreased mortality and has been protective against many diseases. Now, the question is, in Lebanon, probably if I understood the question right, there are many dietitians referring patients to DNA testing to prescribe diets. I'm less keen on supporting this referral. The evidence that we have regarding diet-gene interactions is in its infancy stage, and to prescribe a diet based on DNA is quite premature to launch in clinics. It's still in the labs, it's still in papers on PubMed, and I think to be cautious, we're not ready yet to launch a full-fledged DNA-based dietary consultation.
Thank you.
I can say one word, and then, sorry, I know you want to cut it. But there was one interesting thing I forgot my train of thoughts. No, but I know what I was going to say. It's very important that it's very well known that if you migrate from one part of the world to the other, suddenly you become predisposed to things, specifically cancers and things relating to diet or other environmental stresses. So I think there's quite a bit of evidence that you can benefit from different things even if you live somewhere else. Nutrigenomics is very interesting. Precision medicine is coming, and so I think that's but it's an exciting area to approach, but I don't think you can make recommendations yet.
Thank you.
Sorry. Thank you. I need to talk to her a bit more.
Everyone, lunch is served outside. Please be back here promptly at 1:15 so we can continue and kickstart the technology track. Thank you.
Everyone, please take your seats. We will start. The second track, Applications of Data Science in Technology. This track is moderated by Dr. Fatima Abu Salim. Dr. Abu Salim holds a PhD in computing from the University of Oxford. She's associate professor at the Computer Science Department and member of the Linear Algebra and High Performance Simulations group at AUB. Her main research interests are interdisciplinary, focusing on parallel and cache-efficient algorithm engineering with applications in computing algebra, and is currently pursuing work in reference to big data distributed processing using Apache Spark. She has served on a number of professional positions related to supercomputing, such as Secretary of SIAM's Activity Group on Supercomputing, as well as on the committees of related conferences. She is also Associate Editor for Elsevier's Journal of Parallel and Distributed Computing. Dr. Abu Salim?
Hello, everyone. I'm very honored to be moderating this session on technology, coming from the Computer Science Department, where we're offering for the first time in AB an introduction to data science course. The main organizers, Dr. Moussaoui and Fira, also being former computer science graduates, this couldn't have been a more fitting place for us. This session is also, I think, very sort of telling. This is a group of women who really have been challenging themselves in a notoriously very difficult environment for women, traditionally speaking. And now we're adding this extra layer for data science. So this is really, I salute these wonderful 5 speakers we're going to hear today. First speaker is not around, but her talk has been pre-recorded, and she'll be joining us for questions right after her talk is finished. Dr. Aïssa Bezar-Benner is a professor and the director of Data Science Laboratory in the Department of Mechanical and Industrial Engineering, Ryerson University. She's the director of Big Data in the Office of Provost and vice president academic at Ryerson University. She's a faculty research fellow of IBM Toronto Labs Center for Advanced Studies and affiliate research scientist in St. Michael's Hospital in Toronto. Her current research focuses big data applications to tackle the problem of decision-making under uncertainty by using machine learning methods and graph theory to analyze complex structures in big data to build recommender systems and predictive models. She's a member of AAAI, Informs, AIS, and senior member of IEEE. So welcome, please, and I think we're ready to see watch the thing. Okay.
Good afternoon, ladies and gentlemen. It's a pleasure and an honor for me to be the keynote speaker at this conference. And I'm very sorry that I couldn't make it in person this time, and hope that, in the coming years, I will be able to travel and meet everyone in person. So today, I will talk about my research in data science and analytics, and I run a lab called Data Science Lab here in Toronto at Ryerson University. I will talk about the overview of the lab, our approach, how we conduct data science projects. Then I will talk about examples of past and current research work. Then I will briefly talk about what is novelty in our research, why people come and work with us, and then conclude with the 2 training programs we have been running in data science and analytics. And I think at the end, there will be a 5 minutes question and answer session that I will be Skyping in to be able to answer your questions. We are an interdisciplinary group of people, so we have faculty members from different disciplines, industrial engineering, information systems, computer science, and math. We have postdoctoral research fellows, PhD students, and master's students. So our research is big data, using machine learning algorithms, doing extensive data analytics to build some intelligent algorithms, as they call them, cognitive algorithms recently, to be able to build various recommendation systems in different research domains, which are, life sciences, software analytics, finance, other industries. These are some of the research highlights that summarizes our past and current projects with industry. We have been working with one of the major hospitals, Toronto, called St. Mike's Hospital. We have a project called Operating Room Project, where we are looking into increasing efficiencies in the operations room. We have another project with emergency room efficiency. And we also work with them to build a electronic data warehouse to be able to analyze hospital-wide data. We work with some of the researchers with the insurance company, predict disability, short-term and long-term disability cases by looking at the drug usage of the patient. We have projects with IBM. One of them is IBM Watson. We have a project that we build context-aware algorithms for the Watson project itself. Another project we have with IBM Toronto Labs is in the area of software engineering. So we have a tool called Dione. So our past projects include BlackBerry and Globe and Mail, where we build some recommender systems to capture point of interest and people's taste to recommend similar apps to BlackBerry users. And in the case of Globe and Mail, which is the major newspaper here in Canada, we built a recommendation system where to put the articles or ads near which article based on previous user behavior on the web. We also work with startups like one company wanted to have bandwidth allocation on their digital billboards. So we work with them to optimize the real estate space on the digital billboards. We had a project and a paper where we analyzed the customer behavior on Amazon, Walmart websites and made a comparison of fully online and brick and mortar and online operations. One of our projects, current projects, is with Toronto Stock Exchange. We analyze intraday trading data to predict trading patterns in the stock market. We just finished a project with one of the major insurance companies, Manulife, in Canada, and our project was on insurance risk management to predict the lapse rates in their life insurance business. So we do, as we call, consulting type of activities. So we create practical solutions and develop proof of concepts, tools, and do technology transfer to various industries. We have a very disciplined approach how to conduct these projects in real life. So we have a book chapter here that we analyzed how to conduct data science projects. This is software engineering domain specific. However, the approach is transferable to all other industries. My co-authors are my previous PhD students. This is a blueprint of how to conduct a project. This book chapter is about our 10 years worth of experience with industry. Follow this path. So we select the problem, we extract the data, we describe the data by employing descriptive analytics, and then we build predictive models to predict for certain different outcomes. So it's really important that we follow this path, and then at each step we have to be careful about selecting the relevant problem, understanding the process of data extraction, and then to gain insights and intuition into the data, and then do the predictive analytics. So this part is really the most critical, because this is probably the least amount of time that we spend, because anything and everything we do at this part will determine what kind of algorithm we will be using at the end. The data science skill set is really important to be able to successfully deliver these projects. So, the depth and breadth of knowledge is very important. So in the depth, which is the T, this direction, we have to have machine learning expertise, statistics, and domain knowledge. So including myself, everyone, if necessary, takes courses to gain the domain knowledge. We always make sure that the partners are part of the project. The breadth is software engineering. So at this, axis, everybody needs to know how to code their own algorithms to be able to extract data. And everyone has to have a strong communication skills, which is the soft skills, as they call it, and have some business acumen in order to be able to properly communicate with our industry partners. So the idea is we would like to see the big picture, not get lost in the details. So depending on where you look at this elephant, you can see that maybe it's a fan, maybe it's a hose, maybe it's a tree, maybe it's a wall, or maybe it's a rope. However, it's just the elephant, giant elephant. Unless you look at the big picture from outside, you won't be able to see that. So we have to avoid these localized views of each blind man, which leads to a biased conclusion at the end. The more students and postdocs dirty their hands with data extraction and running algorithms and understanding the domain, the better they will be. Now I would like to talk about our current and past projects, just to give you a flavor of what those projects are. Now I will give you some more details. So the first case is the application recommendation. This is the project we did with BlackBerry. So we have a paper, and the purpose of the recommender is to recommend relevant or novel applications to mobile phone users. At the time, the company's current recommendations was to watch the developers, to suggest trending applications and recommend top grossing applications to their customers. We looked at the different types of recommender systems: popularity based, taste graph based, and contact based. The second project with the same company is point of interest recommendation. So on top of the taste graph, they wanted to include interesting locations, points of interest, so that they could make a recommendation. Say I am in a shopping mall, and they know my tastes, and I am similar to my friend Mary. If I purchase a pair of shoes, and Mary gets a recommendation that if she's at a nearby location, that your friend Aisha bought the shoes, and you have similar tastes, and you are near to the same location, and you can go ahead and take a look at those shoes. This was a collaborative, filtering approach, and on a real-time basis. And it was a massive data because of the locations and the user tastes, etc. The data was kept in Hadoop clusters, so we mined the data for 61 million users and built the recommender system. We have a paper. Third case is with a startup company, a project called Billboard Placement Optimization. They had more than 1,000 electronic billboards. So these billboards were refreshed on an hourly basis. So we used external data sets. So there is an open traffic data sets in the US. So these billboards were in the corridor of Texas to Atlanta. We were able to get the open traffic data set to understand the demographics of people and the traffic density in different hours of the day, together with the billboard locations. So we built the recommender system by using linear programming techniques to maximize the views per cost for this company. And again, this is a paper presented at a conference. The fourth case is with the newspaper, news recommendations. So we have in total 3 projects with them. One of the projects was to recommend relevant news articles for their premium users on their website by mining the user behavior on the web. So it's basically 16 gigabytes per day of raw data logs that were kept in Hadoop clusters. And we mined the user reading history and analyzed articles to build a collaborative filtering-based recommender system. We tried different machine learning models to predict the shelf life of the news articles and the temporal behaviors of their users. It's a paper in a recommender systems conference. Another case is with the hospital in healthcare domain, operations room analytics. As they say, the surgeons say, whatever happens in the operating room stays in the operating room, like going to Las Vegas. So they would like to understand the impact and relationship of patient-related as well as intraoperative technical and non-technical and environmental factors on clinical outcomes. So technical, non-technical, intraoperative outcomes are basically the behavior of surgeons, nurses, and their interactions with each other during the operation. So if I know the impact of these teams, so I can, team up X type of surgeons with Y type of nurses, so that I can minimize the error. We are implementing a multi-channel data recording device in the operating room. So we basically record anything and everything that goes on in the operating room, both audio and visual. We started performing some analysis on the first year's data to understand the human and technology performance and to be able to analyze some patterns and risks during the operation. We published our initial results in the Canadian Journal of Surgery. The next case is with an insurance company. It's predictive analytics in life insurance. So the problem was to understand and predict the lapse rate in their life insurance business to determine, what are the factors that cause this lapse rate. So we looked at correlations of different variables and see if any of the parameters are important indicator of the lapse rate. And we looked at all internal parameters, internal data, and over the years how this how each and every parameter affects the lapse rate. And we also looked at the weighted parallel coordinates before 2008 in terms of how at each stage the lapse rate changes and is being affected. Again, we found some interesting insights. So we found, some of these internal parameters that they relied on were not indicator of lapse rate prediction. So we found a new set of parameters that they were not using. And we also, with the parallel coordinates, showed that before 2008 and after 2008, people's behavior changed dramatically. So this was due to some external economic factors that they were not taking into consideration. We have a conference paper at the Informs this year. The other project, an ongoing project, is the project that we do with Toronto Stock Exchange. We are looking at customer and cross-sell segmentation opportunities to capture different kinds of behavior in the stock market trading. Looking at, whether the stock exchange should build speed bumps during the trading and to capture some high frequency trading behavior that they may not be aware, so that they can regulate properly. And we also looked at the impact of news, tweets, and other events on stock prices. And this is our paper on the Twitter bullishness index this summer that we showed some interesting findings of using Twitter tweets to predict certain stock behavior. So we are mostly now focusing on high frequency trading activity and the impact of speed bumps on the overall stock market, both from the regulator point of view and for the consumer and broker point of view. Another case, as I mentioned earlier, is our work with IBM Watson. IBM Watson, as you may know, is an NLP platform. You upload certain corpuses, and then the users query the system to get relevant recommendations on their queries. We are capturing the user behavior. Again, we have a 1 year worth of Watson Analytics user data and their preferences, and then we would like to predict which analytics will be requested by the user. So in terms of, in this case, what kind of keywords they prefer in searching their questions, and what kind of presentation tools they use. So these 3 charts are examples of our 1 year worth of data analytics to show whether the users prefer bar charts over pie charts, and is there a difference between the type of user. So for example, if university professors prefer bar charts over pie charts, and if industry people are more into pie charts, etc. We would like to capture context and include the context in the recommender algorithm. So we would like to build some intelligence into the algorithm to include the contextual variables at different stages of the process to build this context-aware algorithm. Again, we had a paper in this year's CASCON. Another project with IBM is called Dione and test case prioritization. So we have a tool called Dione. That's a software analytics tool that we built over a period of 10 years. 2 years ago, IBM decided to invest in this tool and to integrate to their rational team concert product group. We are using Dione to prioritize test cases. So this is a pilot or pet project that we chose to do a proof of concept on Dione. Basically, Dione is a platform agnostic software delivery intelligence and predictive analytics tool. So it extracts metrics from the software repositories, does data analysis, and it has a predictive engine, builds predictive models using machine learning algorithms to predict defects, to predict developer tester behavior, etc. We are working on the integration of Dione to RTC, and also using test case prioritization as our pilot project to do the proof of concept of Dione. So our initial paper on the tool was published in 2012 FSC conference. Why people come and work with us? What is the novelty in our research? So we are basically working on some practical concerns, current concerns on recommenders. So one concern is, how can we change or predict behavior? So some people work on computational cost, so that's not our area of research. And another problem is, once you build a recommender system, what would be the update frequency of those recommendations? So how frequently you should be giving updates? So we are very much interested in this topic. Another issue is the performance measures. So once we have the recommender system in place, how are we going to, measure the performance of our recommendations? So what are the evaluation methods? User experience is another area of research, that how can we, again, predict, user experience or, behavior from the user experience. The randomness is another area. The other important problem is data sparsity and cold start. So our, context-aware recommender system is a problem of cold start. So, for example, if a new user comes, how am I going to find out about the context and be able to make relevant recommendations? And data sparsity is a big problem in anything and everything we do. How can we overcome if I don't have enough data, for example? That's a very interesting research area for us. So going forward, what are the current trends and algorithms? Sorry, it's current trends. We are working on building cognitive algorithms which learn, adapt, reason with the context. Algorithms like, reinforcement learning, Bayesian networks, neural networks, deep learning, and all that are, in this category. We are very much interested in, incorporating biases into algorithms. So previously, with one of my previous PhD students, we worked on cognitive biases. So to understand, the impact of cognitive biases based on Kahneman's work to build algorithms that detect cognitive biases. And we worked specifically on confirmation bias out of 5-6 different bias types. And so we would like to continue with that because, at the end of the day, we are trying to mimic individual decision making, and as individuals, we are biased on, various ways. And how can we teach the algorithm to, learn those biases and maybe overcome those biases? Another area is social learning, homophily, social influence. So how can we include these concepts into the algorithms that the algorithm can detect those differences? The new and coming area of research is embeddings, techniques like matrix factorization to address the data sparsity problem, gradient boosted decision trees, and as I said, reinforcement learning types of algorithms that learns from its environment and makes a decision there and then. They all, are very interdisciplinary approaches, roots in cognitive psychology. So again, we have in the past, a couple of papers to address some of these problems. So these are some of the references, our own, publications and others. I will talk briefly about the training programs that we run here in Ryerson out of my lab. Our aim is to produce leading data analytics professionals. So we have custom tailored short courses, such as for, half a day board members, 1 day or 2 days for senior management, and 5 days boot camps. Also, we have longer term programs, degree programs. We have a certificate in data analytics, big data, and Master of Science program in data science. The certificate program was launched in September 2014. So it's fully aligned with the CAPS Informs certification program. CAPS is the Certified Analytics Professional under Informs. So this is a 6-course program. Actually, all courses are in hybrid form, and we run some of them in fully online format. So we have more than 500 students at the moment. It's been a very successful program and highly demanded. We launched in fall 2016 a Master of Science program in data science and analytics. This is a nicely, laddering up program on top of the, certificate program. So if you look at the knowledge hierarchy of an organization, these are low-level, analytics jobs. And these are, mid-level and, higher level, and this is the, senior, management. Our programs are placed here. So this is the certificate program, and this is the master's program that, ladders on top of it. So these are, basically, the basic skills in business analysis and analytics and all that, our various undergrad programs give those skills in, industrial engineering, business, IT, etc., as we call in Ryerson, Big Data Initiative. So we would like to, own the whole space to provide the, knowledge workers in the knowledge hierarchy of the organization. Ryerson also is leading a consortium called Canada's Big Data Consortium, composed of members, other universities, industry, and government members. So we launched a Big Data Talent Gap white paper a year ago. And now the consortium is in its second phase that we have 2 working groups. We are still the leading organization to look into predictive health and monetization of big data. In about a month or so, each working group will be publishing their white papers. This is a AUB Stanford Women in Data Science conference. I just wanted to make a point that it's the girl power in data science lab. So 62% of the lab population are ladies. Thank you so much again for Lama and her team for giving me the opportunity to speak to you today. I would very much like to visit Beirut and meet every one of you in person. And I hope that remotely and electronically we could find a way to collaborate in the future. Again, thank you so much for your time and attention.
Wonderful. So thank you, Dr. Banner. Dr. Banner is going to be live now, available for a 5-minute question and answer session, and she'll be able to see us via this camera. So I believe we can just, right? Is that true? Is Dr. Banner with us now?
Yeah, hi, I'm here.
Hello, yes, great. So we can take questions now? Yes, so there seems to be a question over there. I think we'll need a microphone.
Terrific. Thank you. I hope you can hear us. It's brave of you to participate via this medium here with us in Lebanon. Thank you. I really appreciated hearing all the great things that your lab is doing. It's really exciting to see such a developed lab with so many projects in data science. I'm wondering if you could give advice or information about how one grows a lab like that. Is it one big massive grant that allows you to grow a lab, or how does it work to develop such a facility in an academic institution? Thank you.
Thank you. I mean, the only secret is working very hard and believing in your work. So I never start a project with a money discussion. So I just go to an industry partner. I always have a presentation of my previous work and try to understand what the industry partner's problem is, and come up with a practical solution and ask for data, as simply that. And you only need one good PhD student to start with. And then, you basically deliver the partner's requirements with an angle to be able to publish. So in each and every project, we have at least 1 or 2 publications. And then you grow, you start with 1 student, with 1 project, and the projects and the students follow. There's no other secret, just work very hard and do your job well.
All right. Any other questions? Yes, a couple of them maybe. So we have Fida here and a lady at the back. So.
I really liked how you drew the pyramid to try to address the skill set of data scientists as they move up the hierarchy within their organization. Can you tell us a little bit about how this skill set evolves, and what kind of new skill set do they have to kind of capture as they move up, or other skill set that they won't need anymore as they move up their organization leadership path?
Yeah, I think at the beginning of the talk, I talked about the T-shaped individual, so the breadth and the depth. So both our programs and the skill set I need in my lab is that T-shape. As the individual grows, they will be stronger in their core skills of machine learning, math, stats, etc., while they are building their skills in coding, domain knowledge, and communication skills. So as people get more mature and become more senior, they will develop better business skills and better understand business objectives to match with technical skills. But at the beginning, the core is really the technical skills. I go to many conferences, education conferences and all that stuff to talk about our programs and curricula. And many people talk about soft skills, soft skills. Yes, of course, soft skills are important, but as long as you have the technical skills. So data science is a topic that you must have technical skills. My analogy is that you can't be the head surgeon if you are not a surgeon in a hospital. So you just can't claim that I have great skills to communicate with the nurses and I'm going to operate the patient. So in data science, the main thing is your technical skills, and as the individual matures, they will build the soft skills along the way. I think the T-shape that I described will always be needed.
I think we have a room for one last question before we resume. So, over there.
All right. Thank you so much for this interesting presentation. I need to ask you about the application on business, like you mentioned the project about digital billboards. So, I mean, right now we have the platforms on Google and Facebook that can show the advertisers the ads that are working and the ads that are not working with the CTR, and they even advise the advertisers when to optimize and when to change. So, what is the difference between these platforms and the project that you are working in? And I have a second question. You said if we need to be, let's say, a part of the team of your project, you mentioned machine learning, statistics, domain knowledge. So are there specific programs that you recommend to learn? And what are they? Thank you.
Okay. So, of course, mainstream companies like Google, Amazon, they all work on the same problems and similar projects. So our solutions most probably are quite similar. What we do is, I don't know exactly what their algorithms are, but in our projects, basically, in the case of ad recommendation, billboards, etc. So we analyze the customer's data, especially on the web, for example. We analyze the web customers' past behavior. We understand those patterns, and then we build a predictive algorithm using different machine learning methods to predict how the customer will, behave, in the future, and how the, ads or articles should be ranked. So probably we are using quite similar machine learning algorithms. The only thing we do is we find the best fit algorithm given the customer's data. So your second question was what one needs to learn to be able to do these projects, I think. Yeah. So one needs to have a strong background in math, statistics, and computer science. And so that's the basic skills in data science you need in order to build the machine learning skills on top of it. So there are various programs and courses. So if someone is not from a computer science field, there are 3-4 basic computer science courses in a given computer science curriculum that you can take those courses, I'm sure, at the university or in open source courses, and then build the other skills on top of it.
All right, thank you. Thank you very much. I think we're ready to welcome our second speaker, Dr. Nasreen Ghaddar, who's Qatar Chair of Energy Studies and Professor of Mechanical Engineering and Director of the Manib and Angela Masri Institute of Energy and Natural Resources at AUB. Her primary research focus is in the area of efficient cooling, solar energy applications, energy conversion, and bioheat modeling and thermal comfort. Sorry? Oh, sorry. So, yes, of course. I'm sorry. I didn't notice. So, Dr. Ben is still with us. We need to thank her, I think.
Thank you.
Sorry. It's just unseen. I'm very sorry.
That's okay.
I'm not used to these sort of Skype on top of my head. I'm sorry.
That's fine.
So,
thank you. Bye-bye.
Sorry. I'll carry on with the introduction. Dr. Ghaddar is also a fellow of the American Society of Mechanical Engineers, the Islamic World Academy of Sciences, and the Lebanese Academy of Science. She's published more than 120 papers, peer-reviewed journal articles, and more than 100 conference proceedings articles. In 2014, she was listed by Muslim Science among the top 20 most influential women in science in the Islamic world. Dr. Ghaddar will be speaking about data science and modeling. Thank you.
Hi everyone, I'm honored to be here today to the data science conference. I have to tell you, I have an engineering background and I'm good in modeling, simulation, experimental work, technology, physics. But I came, to deal with data a lot, and I'm selecting one project that we have indulged in recently that I thought it would be most relevant to the conference today. So we will see what I have chosen to talk about. I'm saying data science and modeling to impact the human behavior for energy conservation. This is a little bit touching on what Dr. Beni has talked about in terms of data analytics to influence consumer behavior or people behavior. But let's see what I'm trying to do here to conserve energy. How can I influence behavior to conserve energy? Really, we're looking at innovative means to conserve energy in buildings. This is work, that we've been working on for the past 20 years with colleagues, with students, with PhD students now. And we realized that we are focusing on buildings because almost 60% of electrical energy consumption in buildings is to meet air conditioning needs. We are here in air-conditioned space. It's now heating, not cooling, but still in the summer we have to cool it. So any air conditioning system design should provide two requirements. One, thermal comfort need of the occupants to increase their productivity. You can't work if you are sweating and it's very warm in the room, and you will just stop being productive. You can't study even in this situation. And we also would like to provide, the AC system should provide fresh air needs of occupants by providing breathable air of high air quality. Otherwise, people will get sick and so on. And remember that the air distribution in the room is also responsible for transmission of many of, if you have an infected person, healthy person. So these are issues of air conditioning design. These requirements must be met. This is in the recent years, it's an emphasis they have to be done at minimal energy consumption through effective control of the HVAC system. And when I say effective control, I'm talking about people and people behavior. And this is what we mean by energy efficiency. So within, with what is happening in global warming, the energy demand for air conditioning is going to increase over time. So we'd better address this issue. What is our approach to air conditioning? And this is an approach really we have worked on for the past 10, 15 years, and we've done a lot in. Current systems, air conditioning systems, focus on cooling and heating the room air to a homogeneous temperature. If I measure the air temperature, room temperature here or up there, it's the same. You have a fully mixed, homogeneous feeling of air temperature. Our focus is really the human. We'd like to provide the comfort, air quality needs of the human directly to the person at all times, without having to worry about the air up there or in places where people that are not occupied. So we'd like to integrate the human body with the built environment and the system in a way that would enable the efficient use of air conditioning system and hence provide energy conservation. So we've been working on development of a human body model based on physiology, of course, and some empiricism that can interact with the surrounding and predict the thermal comfort of people and also the system requirements in terms of performance and energy consumption. And this would inform what the change needs to be done to the surrounding of the human by the system to avoid, for example, overcooling or any sensation of discomfort. So how do I quantify comfort? Current approach for quantifying thermal comfort, which is something related to the physiology, because the human body generates, heat all the time for the metabolism and so on, and it has its own thermoregulatory responses related to the environment and the perception of people about their setting. So the oldest model on human thermal comfort was actually developed by Fanger, and the parameters that control this at a given activity level or metabolic rate are the air temperature and air velocity mainly, all right? Of course, clothing resistance and humidity to some effect. So we can always get the total a person is in thermal neutrality when the heat generated by the person is equal to the heat lost to the environment. So they are in neutral state. They are not stressed. And Fanger has developed what we call a scale from -3 to +3, where 0 represents the neutral state, which is supposed to be that you are in comfort. However, this approach has limitations because these models, it was semi-empirical. Secondly, it doesn't apply for transients or when you have non-uniform environment where a wall is hot, another place is cold, and you're just not comfortable with this non-uniformity. And then physiology did not enter into the model except with the activity level. Fanger, in developing this, he has conducted 2,000 human subject experiments in different environments, the clothing, resistance, whatever, to come up with the model. But for us, this is a limitation because all that model is really related to the environment. It's not related to the human. So there was another model that was developed by Zhang at Berkeley, where it considered the segmental comfort or local comfort and the overall comfort in transients, in non-uniform environment, and provided a scale from -4 to +4, or -4 very uncomfortable or intolerable, and 4 is supposed to be best comfort. But this was done through correlations, and these correlations relate the transient global and local thermal comfort and sensation of the person to the segmental skin temperature. What's the skin temperature of the back, the front? There are certain body elements that are influential in terms of quantifying the human comfort. And what Zhang did, and all right, her work is cited a lot, but because you're relating the comfort to the physiology, skin temperature, core temperature, and the rate of change of these temperatures in the segmental body in the influential body segments. This is what helped us to move to the approach of integrating human physiology, space, and system. Because we have developed a bioheat model, I'll talk about it shortly, and the introduction, so what we did with this, we had a bioheat model that can predict the thermal response of the human. We connected this to the environment, to the system, and we were able to predict the state of comfort of the person. And this approach has led us to introduce new systems, such as localized and personalized air conditioning and ventilators, to provide comfort and fresh air directly to the person and not to the environment. And also to think of new operational control strategies of systems, taking into account the human behavior and interaction with technology. So if you allow the occupant to control their own comfort, you actually save energy. If you improve the thermostat usability, you can come up with some sort of improvement of a programmable thermostat to be able to meet the human comfort needs all the time. And I'll talk about this for the rest of the lecture. And this could change people's behavior, and I'll tell you how. But the basic tool that we have used to predict the comfort was actually the bioheat model and comfort assessment tool. We've been using this. It took 10 years to get this to this stage. Anyway, the model will give you the skin and core temperatures and the rate of change based on all the input parameters, activity level, and so on. So being equipped with predictive models of comfort, space, and systems, we are able now to change to the focus on the human and think of energy efficiency in this way. All right? We worked on many systems, and based on a lot of research done, reduction in energy use for AC can be reduced between 30 to 70% if we use these systems. But then, if I come to the operation, the conventional system control for comfort, I think you do that all the time without knowing. You are controlling your comfort through the thermostat. And this is the device that basically changes the air temperature in the space so that you can feel comfortable. All right? So what's the relevance here? Currently, the thermostat is in some location in the room. You change the setting, it will cool the air distribution system will respond, and a whole series of things you're not aware of in the air conditioning system happen, including on and off use of the compressor, whatever, and these changes could be very tolling on the energy consumption of the system. So what we're looking for in the user control for the programmable thermostat for maximizing comfort, using some acceptable control strategies for the human. There are many designs, all right? So comfort can be provided people through the thermostat, and the responsibility is on us to decide how we cool or heat our homes. And a lot of savings could be done, but the problem is that people do not use that tool. They don't understand it. I've collected data on this. People have so many misconceptions about the thermostat, and they use it like a valve, on, off. They don't know what's in there. They always complain about this. It's too complicated to use. The buttons are so small, we can't use. The age-dependent problems with the programming, the unpredictable time of people to come home. So how should I set this thing? Because if I'm not using it, I could be, actually, if it is used properly, you could be saving up to 30% of the energy. So the objective, I have 4 more slides. لا أكتر شوي. Objective, we want to improve thermal comfort control. So thermostat user design interface, I want a friendly interface so that I have the user interaction to save energy. And at the same time, I want to build in a smart response to human needs for comfort when using the air conditioning, even in an on-off mode. So the human could see it as on-off. But you have programmed it in a way after you understood people preferences so that this gets reflected. And then develop that interface to promote energy savings by introducing in new features that takes into consideration the non-continuous air conditioning that happens in Lebanese homes. And the methods, we have to do data collection, analysis, conduct online surveys, do controlled experiments to interview people, see their preferences, their knowledge about this, what function works, what don't, and then monitor the energy consumption in certain homes, in some homes, as a sample to note what are the features that are most acceptable by people or functions. And then we have to do modeling and validation because we want our models to predict that behavior, but we want to make them quick. So we can eventually do an improvement and then have a design recommendation. But just to tell you something about the initial survey work that has been done, still we're aiming to reach a 300 home sample, that in Lebanon, the average, split unit type in homes is a 3. We've taken 4 areas of Lebanon. Total number of households, it's 60 or 70, but as I said, that number is going to increase. So if we ask people if they are aware about the thermostat use, you will notice that there is really lack of awareness of what that function is in their homes. Some don't use it even at all. So if we look at Lebanese homes, 60% are occupied and 40% are vacant. And of those that are vacant, 20% keep the AC on. At the same time, the potential to such discomfort that is present with the flexible feature of thermostat, people are totally thinking, they are all the time changing that function. They feel comfortable, uncomfortable. That's not a good way to deal with energy consumption because when you turn the system on and off, this is always starting up the compressor, even if the fan is on. So you're actually using always your AC in a startup mode that consumes a lot of energy. And if we look at comparison benchmark about existence of typical programmable thermostat, we notice that also Lebanese people, they don't have programmable thermostat, and even they do, if they have it, they don't use it. So this is compared with the studies that are done in the West. There is much more use of these thermostats. That's the last slide. So the preliminary results have showed that people are using thermostat in an on-off fashion. Most set the thermostat at very low temperature and never change it. They go to sleep, it gets very cold, they can't change it. The system is just using on and off frequently. When the temperature becomes uncomfortably low, people either open the window, turn off the AC, or raise the thermostat set point, which results again in a very inefficient operation. So next, there are features that will allow us to program the thermostat based on the perception. So we have to do a human subject test and do monitoring of homes to see the pattern of energy consumption, its relation to room temperature, and then program these features directly in the thermostat, although it will be seen by the consumer as on-off or as a button, but it will be displaying the temperature of the space, how much time it is going to take to reach comfort, because we have the predictive models, and how much energy will be consumed. If we get to that, we will have a design that fits our Lebanese culture, because we use our homes in a very different way due to electricity and intermittency. Even if you leave the air conditioning on, like AUB, then somebody else has to turn it on again when we get the electricity cut off. So these things will affect how we look at the design. Thank you. 2 minutes, fine. Okay.
So I think the arrangement is for us to receive questions after all the speakers have finished during a 15-minute question and answer. And I can now welcome Dr. Mariette Awad, who's Associate Professor in the Electrical and Computer Engineering Department at AUB. She received her PhD in Electrical Engineering in 2007 and has been a visiting professor at Virginia Commonwealth University, Intel Mobile Group, and MIT. Dr. Awad was invited by CVC Labs, Google, and Qualcomm to present her work in machine learning and image processing. She's published the book efficient machine learning in 2015 and has taken part in numerous conferences and as well as managing several grants. She's an active member in IEEE and review of her IEEE transactions. She'll be speaking to us about applied machine learning applied to power, computer, architecture, health, and multimedia.
Hello, everyone. It's really an honor for me to be here to present some of my work on machine learning applied to performance optimization, social and effective computing. So in my talk, I will go over, I'll try to answer 3 questions, the 3 W's of the machine learning. Why now? Why everyone is really on this track? Why machine learning? What is machine learning? If you want to describe it in non-engineering and dilute all the math and the algorithms from that term, what would machine learning be? And then the last W that I would like to present to you is the where, and more specifically, where in our lab we have used machine learning. So why now is the era of machine learning? I think it's because we have the trinity of big data. You've heard so much about it all today and probably in the remaining sessions as well. So we have the data, we have the hardware, and we have the algorithms. So a lady had asked before, if you want to be in the machine learning, you could be at the algorithms level, but at the same time, to really be able to produce meaningful algorithms along the line of deep learning, swarm, heuristics, bio-inspired, statistical, you name it, you have to have data, and the data has to be well acquired, and this is why the hardware, and it's spanning from the IoT, the cheapy wearables that we have, the smartphones, the data centers, and now the fog computing. So if you want to be in any of these categories, eventually you're working indirectly in the machine learning. We need to be able to have the hardware to sense, or the algorithms, the code to be able to synthesize and understand the information from the web. We need to be able to run it efficiently on hardware, and we need to run it according to the algorithm so that it makes sense. So with this trinity together, we could say machine learning is what? Basically, machine learning, if I want to abstract it from the math, is I have data, and then I'm after this function that will make sense from the input that I have to the output that I would like to get. So what is Y going to be learning? How do we prepare X? The input that I have, is it noisy? Where is it coming from? Is it coming from different sources? Do I have to maintain some sort of scalability? What should F look like? Would it be very nonlinear, linear? What type of function would be able to explain my X to my Y? How do I evaluate my F? I spent so much time in my lab developing this function, but then how good is it? How can I really find the boundaries, its performance? And then mostly the $1 million question is really, what is F? What could be the best function for really most of the applications that we touch base on that would really be able to explain everything that we sense we have as a data with respect to the outcome? So with that, I get you to the what, the where. So where's the machine learning applied? This morning and the morning sessions and this afternoon session, we've talked about so many of the machine learning applications, and I'm sure there's tons and tons out there. I've had in my book some other examples, but I picked just the 3 to discuss today with you. It fits probably more the traditional, the engineering background, which is power reduction in adaptive processors. And then I picked 2 other applications that are probably more the artisty or maybe the non-engineer, so that we're not coined with the very traditional people. So power reduction in adaptive processors. Why is that? So now it seems like we live in a very nice era. It's digital. We don't have to worry about writing, printing, mails, all that, old jargon is away. We're talking about connectivity. We're talking about devices that are very smart, IoTs. Maybe the coolers that Professor Ghaddar was mentioning, they will be controlling our life, our smart living. Everything will be so seemingly and nicely operating, and we're just enjoying that. But this really comes, this digital technology era is coming at an expense of much more stress and much more strain on the data centers. And now we talk about farms of data centers and huge computing systems that should really be analyzing all this trend, all this big data, storing it and making sense out of it, which means it is really consuming more power. And with that, some people even went to say, you know, maybe computing is the next new pollutant if we are, from an environmental perspective, looking at things. Irrespective of, we're not talking about the production needs from an electricity perspective to build all these equipments, we're just talking about the runtime and their consumption. And over there in this slide, there are two figures showing the total regional data center power consumption for the EMEA. And you could see these numbers are pretty significant. And this lower table is for the US, showing how much we need in terms of energy, how much we need in terms of power plants, just to make sure we are providing enough of power for our data centers. So why do we want to worry about that? It's because most of the data centers, they do run on generic or standard. They're not, at least for most of the time, they're standard computing platforms, which means that the designer who really built this hardware, this server, and these farms of server, they have designed it in mind to be, on average, good for most of the applications. So if we are doing Skype, we will be exercising different needs from the hardware. If we're doing a YouTube download, we're chatting, we're running simulation on the cloud. So every type of application would require different needs from the hardware. But the hardware that is running in the data centers has been configured, most of its parameters, let's say the branch predictor, the ALUs, and the caches, the memory sizes, all of this has been developed so that it is good on average. So what would be nice, and this is what we have done in this project in collaboration with Intel, we tried to look at what would it take, or how much would I really improve if I were to dynamically change the configuration of my processor when my workload is running. So with that, we were able to see, to use one of the very famous machine learning algorithms, support vector machine for regression. We have adapted it to make sure that we do not underestimate, because this is a major problem. If I do not give enough of power for my microprocessor or my server, the job will become stalled, or it will throttle or something. So I wanted to make sure I can predict, and I want to penalize, I want to avoid the under prediction, because this is not what I want. So we modified this algorithm. We were able to run it on a couple of benchmarks, and we were able to reach a 17.8 decrease in power, which was very interesting. And this resulted in a couple of publications as listed on the slide. So that was my strict engineering, very square example about machine learning and power and optimization and environment and saving the planet. And now I move to something more fun, which is the Arabic bubble speech. Do you know what a bubble speech is? It's another word to refer to the comics. And what we wanted to do here is like, why comics? And probably why Arabic comics? So Arabic comics are around, and we might not be aware, but it has been around for like a century or so. It really expresses our cultural heritage, and it's a way of expressing the culture. Maybe this region has been through a lot of different ideologies, and it's very well captured in these comics. It has diverse content, and it's most of the time very inspiring for children, and I would say even for adults. So what was our research question here when we were looking at this data, at this information? So we had the visual content and the actual text inside this bubble that we analyzed. So we had to run and do some natural language processing to extract the words from the bubble. So we had to write and code something to automatically extract the bubbles, identify the text, do the pre-processing on the text, understand the context, and then map it back to the colors and to the tone and the comics. And we wanted to see if the content from a language perspective was appropriate. And the second question, we wanted to see if the visual was in accordance to the text that was inside. And we found a lot of interesting relationship. So we used the machine learning and the natural language processing, support vector machine also for that. And at the end, we ended up finding a couple of comics traced back to the author, having some, I would say, intentional maybe misdirection and some emotional illusion throughout the optical representation, and this is not matching the semantic messages. Also, this work has been published in a couple of conferences and journals. Another, like maybe a different application for machine learning we worked on is to try to see if we can leverage the media, and more specifically Twitter, to help in managing crisis better. And why Twitter, or why maybe the social media, I would say first, is because we have a lot of information out on the web, and many times the current situation and the relief aid is to go through reports, phone calls, send people on the ground, and so on and so forth. And if you look at the numbers for the natural disaster statistics, they're quite significant. So what we tried to do is we developed a framework to collect a lot of data from the web, images, and map it back to the tweets that goes with it, and understand the context of the text together with the content of the image, and try to see if we can really say that an annotated image is better than just soundings of word. That's like updating the folk statement. And it was very interesting that we were able to describe up to 92.43% using some biologically inspired machine learning algorithm that we also had to modify. So we were able to differentiate between a natural disaster hitting in an urban versus a non-urban environment. And finally, my last slide is about affective computing. So also, we want machine learning to do, all of this maybe skilled or technical challenges for us. But we wanted to see, can machine learning, let's say, move more into something that is somehow more subjective? Maybe recognize the style of a composer, and we're talking about classical composers, just based on, a fragment of their composition. So the style, try to get the era in which this was written. So this is what we try to do. And try to see if from EEG I can also extract the emotion. And this is what we have done, also based on some biologically inspired computing that we also have to modify to make sure that we're capturing the peculiarity of the data. And we reached, interesting results that also were submitted for publication. And with that, I finish my presentation.
Thank you, Mariette. Our next speaker is Dr. Christine Freitag. Yes. Christine leads the data science team at SAP, which is in charge of integrating machine learning into Internet of Things applications. She's shaping the machine learning strategy for SAP's IoT offering and is making IoT applications intelligent. Her vision is that all applications are becoming intelligent, especially in the area of IoT. Christine joined SAP in 2006, and besides her leadership role, has worked as a data scientist in customer projects and in product management for IoT products. She studied computer science and holds a PhD in machine learning from the University of Freiburg and University of Hildesheim. Moreover, she is a mother of 2 children. Christine will be talking about how to integrate data science into IoT applications.
Thank you. I'm really glad that I'm here. Thank you for the invitation. And as it was already said, so I'm heading up a team of data scientists, and by the way, 50% women. And it's really a great team, not only because of the women, but I think women and men work best if there is an equal distribution. So what I will talk about today is how to implement data science in IoT applications. So what is IoT? I think maybe not everybody knows. I give some examples. So what SAP thinks about IoT is the Internet of Things, a network of connected things, especially in industry. So industrial IoT is also called the topic which we are working in. And I have here some examples. For instance, in production, you have production lines which are producing some products. There you need to see to optimize that. So also is about the differentiation in a production line that they do not fail, or you have to predict when they would fail. We have other things like quality management, predictive quality management, to predict whether and when the quality of a product is affected. Then other areas like outside, the ship management, fleet management of cars. So also automotive is a big area where we are working in, but also agriculture, also what we heard before from Professor Dr. Gadar, energy efficiency in cities, so smart cities maybe is something which you have heard before. There it's also about how to get efficient energy consumption, compare your consumption to the consumption of others, using data science, for instance, but also about traffic and parking management, and retail, a little bit different area, but also related to IoT. I would like to start with a small experiment. So say you are in your car and you can't see anything in the front. So that's how actually the world was before in IoT. That means you see only something in the rear mirror, and you have no clue what is happening now and what will happen in the future. So what we are trying to do is, in this work of digitization of the enterprises, to bring data science into the play, to have intelligent solutions which allow you to monitor what is happening now, but of course also to predict what will happen in the future. I want to give you one example. My team is working on this IoT topic, predictive maintenance. So what it means is, for machines, you usually have to maintain them after a while. In the past, you did it in a reactive manner. So if something has happened, a failure has happened, a machine broke down, then you reacted, you called a maintenance engineer, he fixed it, and that's it. Then over the course of the time, there was something called preventive maintenance. That means you are maintaining your assets, your machines in regular intervals, still happening. So many companies still have preventive maintenance. And the next step is condition-based maintenance. That means you look at the current condition of your asset, of your machine. That means, for instance, your car you have drove in the car for, I don't know, 45,000 miles. Then the car should go to the service. And the thing which we are working on now is predictive maintenance. That means you are really taking into account the past data, the current data, and try to predict what is happening next and when a specific machine should go into maintenance. So that's what we are doing. And where I will also give an example how we integrated data science into this application, into this solution. Wrong direction. Before I show how we did that, I would like to talk shortly about the challenges which I see in IoT and big data. So most of them are related to big data because IoT means big data. So we had in our projects, and we had around 30 projects in the last couple of years, we have found really big data. For instance, for airplanes, the new A380 has 40,000 sensors. And that means if you, in data science, you create features, so you create additional things, you might have even more than 40,000. So for instance, take the maximum and the minimum of a sensor value in a time frame. That means really big data, so you have to take care about what platform you are using. Maybe you should not send all the data to a central place, but do edge computing. Maybe you heard about edge computing. That could be a solution to this problem. Another challenge is the velocity of the data coming in. So for instance, for forklifts, a project which we had just recently, we got the sensor data in milliseconds. It's also a very big challenge. Another challenge compared to other areas where data science is applied is the variety of the data. So main data source in IoT is sensor data, time series. For instance, every millisecond, one value, or every second, whatever. Additionally, you also have other sources like images or videos recently. So images, for instance, in the production of cars, you have thermal images of the car parts to detect quality problems. Videos from surveillance in plants, in factories. Then text data, of course, like coming from warranty claims or repair report, maintenance reports, and normal business data, which customer is this, who has this assets. All of this you have to bring together. So that means one problem there is also the uncertainty of the data, called veracity. So the question is, if your data quality is poor, you have missing data, how do you bring all this data together? So it's really the main challenge in the project, that you spend a lot of time in just doing data preparation, data fusion, before you start really doing data science. But the main point I want to make here today is actually how to extract value from the data, because data per se is not valuable, in my opinion. Only if you can detect insights, extract insights from the data, then it gets valuable. So, and that's what I want to show you. And I think you can extract value using automation and machine learning or data science. So that's what we are doing at SAP in this area of IoT. And that's the wrong direction again. I want to emphasize for predictive maintenance what our main challenges are, not around IoT, but more in this area of predictive maintenance and how we solved it. So as I said, high-dimensional data is a problem. What we recommend here, and we are working on, still working on it, to have automatic feature selection. That means you are selecting the sensors and features constructed on top of these sensors, which are most relevant to predict a failure. So that's one topic which we are working on. Second, the problem which we are encountering often at customers is that the customers do not have labeled data, labeled failure data, because either what they are producing is new and they didn't collect any data on the failures which have happened in the past, or it's just not yet done in general. So what we are suggesting there, and we have it already in our solution, is anomaly detection. So instead of really predicting the future, we are detecting abnormal situations. We learn what is normal, and if new data, sensor data comes in, we detect these abnormal patterns. And there, what we think is important to also incorporate user feedback to avoid false alarms. Imagine you do not want to be bothered like every minute with something which is not relevant. That means the system, the data science, machine learning system, has to learn over time what you think is relevant. And that's what we are working on now, on incorporating this feedback from the user, which we call here reinforcement. Next big challenge is the rare failure event problem. That means failures are in general rare, luckily, because if you buy a car which is failing every day or every week, you would not be happy. And that means for the challenge in data science or statistics is that you do not have a lot of data with failure data from the past which you can correlate to the sensor data. Here we need specific methods to tackle this challenge. One of them, which are used in literature, is using ensemble learning. I think it was mentioned today as well in one of the talks. So we are using gradient boosting trees for this, which seem to be good, at least on the data we have used. Next one is about actually deployment of data science into applications. So we have the challenge that models, data science, machine learning models get outdated over time because new data gets collected. So you have to keep the models updated, and you can't do that manually. So you don't want to have a data scientist there pressing a button, retrain, or apply the model to the new data. So you have to have some automation. So what we propose there and have in our solution is model management. So you can have an overview of the models which you have learned, you can update them, you can apply them to new data, and this is done in an automatic fashion. And the last one what we saw, especially in this area of IoT, is that for different industries and even specific customers, you have a really use cases which cannot be tackled by standard algorithms. So what we propose there is to have extensibility. So we offer in our machine learning engine, that's the name of our part of the product, the functionality that you can extend this easily by using R. So if I talk about technology, we are using R there. You can just integrate an R package which you have written into our system and use it in this predictive maintenance machine learning engine. And my last slide here, I want to show how this works together. So first of all, and this has been shown today also, how the steps are in data science, but this specifically now for IoT and predictive maintenance. So we have our data, which then has to, does it work? So we have the business data, sensor data, different data sources which you have to bring together. You have to fuse them, you have to create features, select features. In the future, in our system with automatic feature selection, then you should always apply anomaly detection, because anomaly detection will also show you new unknown failure patterns. If you don't do that and just use normal failure prediction, you will not see the new failure patterns which might occur. So always do anomaly detection, use what is learn what is normal, and detect abnormal situations. At the same time, if you have failures from the past, if you have a failure history, you should use failure prediction using supervised algorithms. And here, we, as I said, we have ensemble learning integrated into our solution. And in the future, there will be reinforcement through user feedback, which is really important to collect data and to avoid false alarms. And additionally, we have the a capability of extensibility, as mentioned, where you can, as a customer or partner, can integrate new algorithms specifically for your use case. And the last one, which I also mentioned, is then that we have model management for all kinds of models, so anomaly detection models, failure prediction models, new models coming from the customer, which is then taking care about which models you have, to retrain them and to apply them to new data. And all of this is then visualized in an application, so you can see a list of your machines or components, and then you have a health status, so you see in color, in a color coding, whether you have a problem with this machine, green or yellow or red, and you have a score, an anomaly score or a probability of failure, which is indicating whether you should do something about it or not. Thank you.
Thank you, Christine. Our last speaker is Dr. Ruwaida Kanj, who's Assistant Electrical and Computer Engineering Professor in the Faculty of Engineering and Architecture at AUB. Her research interests include advanced algorithmic research and development, computer-aided design, statistical simulation methods, modeling and abstraction with particular focus on design for yield, manufacturability and reliability, low-power design methodologies, and volatile and non-volatile memories. Prior to her work at AUB, Dr. Kanj worked at the IBM Research Labs as a research scientist.
Good afternoon, everybody. First, I would like to thank the organizers for inviting me today. Today I will be presenting our work on reliable circuit design, basically focusing on rare event simulations and the sparse regression applications in building this hardware that creates all this data that we are collecting today for our data analytics. So I borrowed this slide from Professor John Kressler in Georgia Tech because I thought it was very interesting. We technologists tend to be very close to our work that we don't really see its effect that it's having on our life and the global impact that it has. And if we take a 50,000 feet look or 50 million feet look from the space, you will see the Earth as a benign planet. Nothing is happening. Maybe everybody is happy there. But then if you look at it from the night time, you will see the effect or the footprint of the human beings. You will start to see the electricity maps. You will start to see the globalization and the effect of humans. Let's morph this figure, turn it a little bit, and let's look in the ocean. There should be no electricity in the ocean. But this is really all the microelectronics or the data that is going from one continent to the other. So you can imagine what we human beings have done to the Earth and what's going on in our lives, okay? So let's look what's happening today. Things are changing very rapidly. We have 40 billion queries of Google per month. We started with one text message in the 90s. Now we have 10 billion messages sent daily. We have 3 billion phones going around in the world. This is creating all the data analytics that's happening. But what is behind that? Who is what's making the data analytics and all this data that's coming out? Well, maybe we look at the phone. The phone is one of the most complicated high-tech devices that have been brought to life. How does it do its work, and how did it come to life? Did it require data analytics to come to life as well? And the answer is yes. We use a lot of math, lot of statistics, lot of rare event simulations, lot of analysis, optimization to make this creature come to life. If you have the heart to rip your iPhone 6 when maybe in a couple of years, if you open it, you will see these little electronic gadgets in there. And if you were to ask a circuit designer, they will tell you, well, it has a 1 gigabit of SD RAM, it has millions of transistors and devices, all in less than 96 millimeter square area. Let's take a closer look at this IBM processor that has millions of transistors. It's smaller than a butterfly. How can you put so many switches, so many functioning elements in such a small area? If we can collect 1,000 people who are very organized in one room, that will be a miracle, right? So how did this miracle come to reality? Okay, so really how small are the integrated circuits? How can we make them function? We are talking about elements that are much smaller than the human hair. If you look at the transistor here, the barrel is really the human hair, and the red dot is really the red blood cell. This is a transistor from 5 or 7 years ago. Today's transistors are 10 times smaller, and engineers are pushing the edge more and more and more. So with the device sizes being this small, with billions of transistors on one little tiny chip, and not too perfect devices, definitely we need an army of engineers, we need an army of tools, and this army of tools really does nothing but data analytics on large dimensions and large data. So let us look at this slide here. As the devices are getting smaller, things are more and more uncertain. While we want our design to look like this, and maybe we expect it to be fabricated with little distortion, what's happening in reality is we're getting different weird shapes that we cannot control the behavior. So things are random, and we are relying on random things to do accurate computations. Okay, so this is the irony here. So if we cannot guarantee the certainty of uncertain designs, this means that no longer we can do banking application, medical application, and nuclear applications. There is no room in error in this. If a single bit flips, a bank account can be wiped down to zero. Nobody wants his bank account to be wiped down to zero, right? So technically, we need very high fidelity, we need high confidentiality, and with a few bits failing, the company is simply going to throw the chip away. So yield is a big problem, statistical optimization is a big problem in design, and because of that, I thought I'll put this picture. Imagine you have a car company, and your fab sends these cars cars, because of very small defects, you end up throwing half of your cars away. This is very costly for the technological companies. We really don't throw cars away, but in chips, we are throwing many of the chips. We are going through many design turnaround cycles, and no designer wants to be the one who is responsible for the single transistor out of the billion transistors that ruined the whole chip. His life will be very miserable. Okay? So, because of this, moving to the technical language now a little bit, we need robust statistical analysis tools. We need methodologies that perform lots of simulations. Physics-based simulations tend to be costly, so we need to build these models that will speed up our simulation. Even traditional Monte Carlo, with the very high constraints on the yield requirements, as we will see next, fails to meet the design requirements in the required time. So we need to come up with faster statistical techniques than Monte Carlo for the rare fail event estimation to be able to deliver these products out there. So I'm not gonna bore you with the math, but really it always boils down to the math. So we are designing the chip. In business world, you want to minimize the cost. We want to minimize the area. In business, you have a constraint on the delivery time. We have constraint on the noise margins, the time or how fast can this really chip do its computations. And then we deal with we deal with the device dimensions, which represent my variables, but we also deal with thousands of process variation variables. So here comes up the dimensionality problem. How am I going to build this optimization for a highly nonlinear circuit that is statistically subject to thousands of variables? Okay? So the basic key that we learn is traditional methods can fail, are not equipped well to deal with these dimensional problems. So we have to go to the math and dig out these data analytics techniques, which will tell us how can we handle such problems. So basically, we proposed for this technique the sparse regression statistical optimization, where we start initially with the physics-based simulations, a few of them. Then we need to reduce the dimensionality of a problem, which is the problem of everybody in data analytics. We then need to accommodate for the statistical effect, and for this case, we do worst case margining once we have the model. We need also to accommodate for the modeling error, because I cannot do my optimization without margining for the modeling error. Once I have all of these taken care of, then we can do the local optimization, and we can try to find the optimal design centering to build this reliable chip that will give me good yield. So why local optimization? Because in local optimization, we can sort of guarantee that this sparse regression model or the linearity of the performance will be accurate enough. We will determine one local optimum and move from one local optimum to another until we converge. So how do we do the sparse regression? What does it mean, sparse regression? If I'm dealing with thousands of variables, this means, is my model really dependent on all of these 1,000 variables? Things in nature are sparse, and the number of parameters that really determine the behavior is smaller than the number that we really believe is affecting things. It's exactly like you are in a classroom. If there is too much noise, there is always one source, main source of the noise that's causing the problem. If you silence that, then everybody else will calm down. This is a classroom example of the sparseness. So we need mathematical techniques, and for this we picked the orthogonal matching pursuit method, where you try to recursively find the variable that has the highest correlation with the performance metric to be able to build regularized model, well-behaved model with low dimensionality. Once we have this regularized behavior model with low dimensionality, then we try to margin for the statistical effect of process variation. So we rewrite our constraints with these new margins. And of course, we then margin for the modeling error. And the final problem that we end up with is the simple, nice, convex optimization, low dimensional problem, which we can deliver an answer that the designer is looking for. So let us look at another problem which also requires data analytics. Today's chip, as we said, have millions of memory bits that are storing our data and our information. And the larger amount of information that we need to process, the larger demand on the memory that we need to build in our chips. So if we want to look at this point, if I want 1 million bits of data to be stored, I will need the yield to be around 90%. This means I'm going to throw away 10% of my chips and not 50% like we said in the car example. If the designer needs to guarantee these low probabilities of 1 in 1 million, he needs to do many, many Monte Carlo simulations. And for this, rare event simulation were being done by variance reduction methods like importance sampling, which give us a speed up of around 1,000 times over traditional Monte Carlo. But of course, designers are not happy. They have many things to analyze. They still need the modeling to be invoked. So again, sparse regression will be invoked in the fast importance sampling simulation so that we can further speed up the turnaround time and the design cycle. So these methodologies were deployed in industry and they were tested in state-of-the-art designs, and we had very good results. So to conclude, technology is the backbone of the smarter planet. When we want to design for reliability and yield, we need robust statistical methods, and most importantly, data science provides the solutions for today's challenging problems of these technological backbones. Finally, I would like to say to all our students, young men and women who are wondering whether we can have a footprint in data science, I tell them yes, we can. Thank you very much.
Thank you very much, Ruwaida. I'd like to invite our 4 speakers. I believe that's only 4 of us left. For a 15-minute question and answer session with the audience, who could also be tweeting their questions at the hashtags that have been announced in the morning. So please, our speakers can take the seat here. Yeah.
Test.
Hello, and thank you for this very interesting lectures. My question is for Dr. Ghaddar first. We saw 2 concepts in your presentation. One was on the heterogeneous nature of cooling the area by focusing on the human body. And I'd like to understand if this is applied or this is just a concept that's not yet applicable, and how it will be applicable in the future. The second part, you were talking about the smart or the connected thermostat, which I'm very well aware we work in that field actually. So I just want to know the link also between the first and the second concepts.
Okay, regarding localized and personalized ventilation, it is being applied and used in certain applications, but they're not widespread. And mainly, their application is in office spaces. You know, task ventilators in many places could represent a way to reduce energy consumption, because each person will have their own ventilator or cool air device. And there are products in the market that can provide that. The thing is about the concept of localization is focusing on the human. We've done a lot of work on this, and we have these devices tested in the lab, on thermal mannequins, on people. And actually, our latest research is about the smart clothing, where you don't even have to worry about the environment. You just focus on the human trunk and the head, and you maintain the body cool by using either phase change material cooling vest or maybe some Well, we have some ideas about cooling the body because we understand the physiology. Now, how do we connect to the thermostat? The thing is, if you are able to predict the human thermal response through modeling, and we have improved this model because it's based on the circulatory energy balances, you know, for the blood flow, for the heat transfer in the body, for the clothing. The combination of this model is very well validated. And we were able to predict, if you put that human as a thermal model in a space, whatever the environment and the exchanges that are happening, we're able to predict the human skin temperature, the human core temperature, and their state of comfort. If I have that tool, then any localization will help to predict how they feel. Now, when I come to connect that to the thermostat, people are not going to use the thermostat except for on-off. It will be interesting for them to know the time it will take if they change the setting to reach the thermal comfort. But how to predict that thermal comfort state and time to provide the person with that knowledge is dependent on the accuracy of our models. So that's why we are at a stage where we have very robust models for predicting physiology, thermal response, and space, and the microclimate of the human is well predicted. And we know what are the significant parts of the body that influence the person's comfort. So I can make changes within the program. I think some of the speakers put this in a different way, but we would like to be able to all the time correct for the human thermal comfort without them knowing we're doing this correction, because we are measuring the environment and we know the response to this environment. I don't know if I made the connection.
Thank you. Mike, second, can I ask another question? For Dr. Christine, about this machine learning and predictive analysis. Are we in a place that predictive analysis is not just for alerting or for giving us an advice? Can it be actually used to operate or to control, or not yet? It's not mature yet to control.
We do not control yet, and I think we are not there, because then we would need a really high accuracy for that. So I think this, at least for what we are doing now in our area, we are not there yet. So the next step for us would be also the prescriptive analytics, that we really like a prescription at the doctor to say what to do, so that the maintenance engineer knows, please take this spare parts with you, do exactly this and this steps. That would be the next, where we are working on already. But really controlling back into the device or so, we are not doing. Maybe it's also not our area of expertise, because that's quite a technical thing. But I also think we are not there yet, because you need to be very sure about the accuracy, high accuracy, and no human would interfere there, because it would control directly. And that's
But do you see that science in the future will start
Yes.
controlling, or we will fear to give the machine the control?
That's another good question about trusting into machines, which we always have also with our customers. So still this is not machines. I mean, it's statistics and so on, machine learning. Still there already we have the problem to convince the users, you know, you can trust in this. And we have methods to build the trust, like showing why, you know, why did the algorithm decide to do that. I don't know whether it really will be the case, but I think that the direction is exactly that. The question whether we humans will allow that or not. Yes.
Dr. Christine,
Yes.
you said that the new Airbus is going to have almost 40,000 sensors, about 7 terabyte data every day. Do you think that this one will help it to be more comfortable to be used from our daily use of cars, the one which have more sensors? It will have more type of faults. It will stop you more than it allow you to move.
it's a good question. Depends on which sensors you have, and often the data which is collected is not collected for really predicting. So that's what we really see at the customers. There's a lot of data, tons of data, but it's not always useful. So the question is, how did Airbus decide and where to put and which sensor to put where? So whether they had that in mind, that they want to predict a specific failure or some situation, I don't know. But not only then the data is useful. That's what we always tell our customers, especially customers who are not yet much in IoT and start with IoT. We try to consult them, how to collect the data and which data is useful for which target.
Thank you. Another question for Dr. Ghaddar. Usually the thermostat is used at hotels or in places where you have a master AC. So the people will be using it to change as per their own desire. If you are going to set it automatic, would it be usually used for all people or how?
What we are proposing, not to set it automatically, but actually keep the features, the interface of the user with the thermostat such that they use it to correct things. But whenever they press a function, that function should be a feature that allows the energy savings to take place. So it's going to take time before when we collect the information about the people data, the measurement of air temperature, what interventions they are using to control the temperature in the space, then we can program this in a better way. And another thing, just about the localization, remember, if you are traveling in airplanes, you're actually having control of your microclimate environment by you have your own environment because you control the cool air that comes to you. It's that concept that came to be considered in the use of spaces and in offices and different places. But always homes are a challenge because residents, they think about their comfort, they don't want to think about energy efficiency. But when they have the data and so on, their behavior changes.
Hi.
We just have perhaps time for 3 more questions and would like to have you carry on the conversation afterwards. So there'll be a coffee break. So 3 more questions and then a coffee break, yes.
Okay. Hi. My question is for Dr. Awad. Actually, you mentioned dealing with Arabic data, Arabic speech bubbles and stuff. So how difficult do you think is to retrieve data and apply the text some sentimental analysis on the text from Arabic language, not from English? How difficult it was to retrieve all this content?
Definitely it was not an easy task, but we wanted to, because I'm not sure if you work in this field, but there's tons of research that was done on sentiment analysis and basically on movies and on reviews. Zomato and all that stuff, and you got these reviews and you compile them. So we wanted to see if we go to the Arabic, and the Arabic language has its own peculiarities and the level of synonyms, and it's totally different than English. So it's not the same. So what you can develop for the English or the non-Arabic language in terms of natural language processing doesn't map one-to-one. So you have to do different data processing steps. But then at the end of the day, you have a lot of dictionaries you can link to, and then you go back to the synonyms and the semantic analysis. You do your own back of words and synthesis, and then at the end of the day, it will go back to be a feature vector that you would be able to input to your machine learning algorithms that are used for any other type of data. So it comes with its challenges, that's for sure.
Thank you.
All right, I'd like to go in with the same question, and this is in terms of language. What about visuals?
Okay, so that's back to the comics.
Yeah.
The visual, we use general approaches because if you're familiar, there are different types of comics, but there are some guidelines. So for you, when you look at an image visually, you can identify the panel, and then the bubble speech, sometimes it's common between 2 panels, and then you have the background and the graphics, different styles. So we went by, we developed an algorithm that automatically goes from like the broader perspective and then go inside. Try to identify the outline, identify the different panels. From the different panel, extract the bubble, because somehow the shape is, so we played a lot on the shape, understanding the shape, doing segmentation on that level. So once you have the two main bodies in every panel, it's the bubble versus the non-bubble. Then inside the bubble, we went for the text, and for the outside of the bubble, we worked at the color level and at the amount of lines that you have, because the more lines you have, it's more complicated. It's not eye-occluding, but it's not pleasant for the eye. So this is a level of complexity. And we wanted to see if what you're selling out or what you're marketing as comics for children, is it the right appropriate tonality in terms of harmony? Are you using the right colors when you talk about, let's say, something related to ethics, moral, or some of the comics that, if you're aware of in Arabic, they have more of a another mission. It's a hidden mission. And over there, we wanted to see if the colors were in harmony. So we played along the level of the image processing outside and then zooming it in.
I have one. There's someone else? Okay, my question is for Dr. Awad as well. So you talked about leveraging Twitter and social media for crisis management, and that the data is found online. So how did you collect the input or the...
So we use Twitter data. So Twitter, if you write some code, you got the JSON, you can get the image, and the tweet that goes with it, with the source and everything. So we did some, not like pre-processing to extract and map the image to the tweet. And we did the same thing along the same spirit as the comics, analyzing the image, and then analyzing the text and amending the two together. So, because I wanted to understand, sometimes it's very difficult when you're talking about damages. It's not that I'm able to recognize a tree versus a car versus whatever. It's damage, and the damage is not repeatable, and it could be of any form. We're talking about natural disaster, not man-made damages. So the text was used to reinforce our image processing and low-level semantic analysis that we have done.
Okay, thank you very much for speakers, and we'll be off for a 15-minute coffee break and then back.
nice. Nice.
قد ايه أعمارهم؟
Thank you. High school.
Sorry. Thank you. Priscilla مين؟ Your
Girls got IT. عم نقول group of girls from. أنا كتير بخاف بس I just بركض.
لا أنا ما بفرجي بس I hate public speaking. I hate it. It's okay. يلا. We can do this.
Is anyone using slides? حدا منكم حد slides?
لا.
Testing 1 2
Hello.
3.
Hi.
Crossing my legs. Sorry.
The mic is on.
I know. My mic is working. Is it on?
Yeah.
Hi, Tariq.
Hi.
We're testing the mic.
Hello. Hello.
Hi.
Had it down. Oh yeah. That's it. Okay.
All right.
Okay. So I want first to announce that we're starting the new track now on business, on the applications of data science in business and finance. And you know, I'm very glad today to be moderating a panel on a topic that I think is pretty hot. We're talking about women entrepreneurs in data science. You know, policymakers, economic development professionals, academics, and most recently even corporations, they love entrepreneurs because they see them as those innovators who are going to come and help with economic growth, create new jobs, and then most importantly, find solutions to those challenges and needs. Some of them, you know, are untapped and others that they create themselves. So we're very excited actually to have here today four entrepreneurs and women who are working in the field of data science. I would like first to introduce Fadwa Mhanna from Markelligent. She's the co-founder of Markelligent, and she mostly uses IoT and big data in her organization, and we'll hear a little bit more about that. Ms. Siroun Chamigyan, who is the co-founder of Kam Kalima, and she focuses more on AI and data analytics for education in her business. Ms. Priscilla Elora Sharouk.
Hi.
She's the co-founder of MyKey and is in computer and network security, but she'll be talking about something else. And Ms. Lubna Rashid, and we're very happy she just joined us from Berlin yesterday. She has done a business in data analytics for refugees, crisis management, and she's currently a PhD candidate at the Technical University of Berlin in Germany. So, before we start our discussion, I wanted to remind the audience about the hashtag of the events, AUB WiDS 17. So please go to your Twitters and tweet your favorite thoughts and ideas that you captured during the date. We'd love to hear them and then be able to share them with everyone else. I would like our panelists, if we can start with a quick round of introductions, a little bit about your path, you know, professional path, how it led you to create your business, and how you crossed path with data science along the way. So, Fadwa?
Okay, first of all, of course, thank you for the invite. It's a great honor to be here. The previous, of course, talks were so impressive, and it's a great honor to be here. I'm an AUB graduate myself. I'm a CCE graduate. I had a long career in the telecom sector, building GSM networks specifically in a multitude of countries, Middle East, North Africa, and the Gulf. 2 years ago, we decided to launch our own startup in IoT platforms, specifically smart city platforms. We are a group of very motivated people. We haven't slept in 2 years almost, so, so we're really living on caffeine. And it's been a tough journey, extremely rewarding, and I'm here to tell you more about it.
Sirun. Hi, my name is Sirun, and I come from the education background. I used to be a teacher for more than 20 years, specializing in science and biology in middle and high school. At the end of the teaching career, I also became an education technology coordinator at the school. So it was my job to train other teachers to use technology effectively in class, not only to deliver curriculum. And I noticed that with the team of Arabic teachers, we noticed there's a gap in Arabic edtech. There's actually a void, especially in the middle and high school level. So we decided to fill that gap, and Kam Kalima was born from that need. So we launched a few months ago, and we're a team also. We have not slept since, and I'm here to share.
So you both are now based in Dubai, or are you based here in Lebanon?
Kam Kalima is based here. I'm moving between here and Dubai.
Hi, everybody. My name is Priscilla. I'm very happy to be here, and thank you all for joining our panel. I'm too, and I'm an AUB grad as well, but I actually graduated, I studied landscape design. So I'm here to show everybody that even if your field is not data science, you might actually end up doing something super cool, like the initiatives that we've been doing with my company. So I co-founded MyKey a couple of years ago. MyKey is a mobile application that allows users within companies to log into their accounts without a username or password. This mobile application is connected to a management portal that allows the management team to see and control where the teams are logging in from, at what time, how, when, and where. So every employee's nightmare, probably, but every employer's dream. While working on MyKey, we actually launched at TechCrunch Disrupt Battlefield in September. That was the launch of MyKey. And while working on the product, we decided, okay, now we're going to focus really hard on lead generation. And we found a need that needed to be filled. And that is when we created Caroline. So funny enough, I'm not here to talk about MyKey. I'm here to talk about a tool that was created internally by my company to help us generate leads and sell to the perfect customer online. I can talk to you a little more about it later. Looking forward to it.
Great. So how old is Caroline now?
Caroline is 2 months old, and she has already generated 800,000 leads, which means that 80% of those actually went from targeting to sign up. So 80% of the people that Caroline targeted actually signed up to the platform.
Wonderful.
Which is really cool.
Great.
Yeah, we like Caroline.
Yeah?
Yeah, she's cool.
Lubna.
Okay, hi everyone. My name is Lubna, and so as a brief introduction, well, I'll try to make it brief. So I will start with a personal story. I'm from Iraq, and I went as a refugee to the US in 2010. Now, you know how in these days, especially people with my kind of background are not, we're quite famous in the world, let's just say. And so I was always the kind of person who never really liked to adhere to social rules. Ask my mom, she's not very happy about that. But I always felt the need that I need to do some kind of change in our part of the world particularly. And so I knew that effective management combined with technology and with data might get me there somehow. So I went to Georgia Tech. I did my master's in industrial engineering, and I was using big data analytics and simulation modeling, particularly to improve healthcare environments. And after that, I worked as a management consulting in a big consulting firm in the US for about 2.5 years, because I felt like that's the best place to get really boot camped in all different kind of management scenarios. Summer 2015 is when I felt like I've had enough and it's time to focus on what I really like in life, and I quit my job. And since then, I began a journey of volunteering in different refugee camps and freelance advising startups and growing social tech companies in different managerial problems they were facing. And now I decided to combine all my passions together and take it to a new level. So I'm doing my PhD focusing on how do we encourage entrepreneurship in the most in the economies and populations that need it the most. And that includes conflict zones, post-conflict zones, and refugee communities. And that's what I'm doing right now.
Excellent. Okay, well, thank you very much for the introductions. No one knows better that challenges and opportunities are two sides of the same coins. You entrepreneur, I guess you provide us with a lot of opportunities to our challenges, but I'm sure you guys have your own challenges to deal with. So we wanted to hear more from you about your own challenges, from a data science perspective in your own areas. Preferably if you can show us this side of the story in terms of the challenges.
Sure. Our company is really specialized in smart cities. And as the previous speech really focused on smart cities, and actually it was really spot on. You need a lot of data. The size of the data that we need to really produce actionable insights has to be at a city level. Now, in our region, definitely, we need to start with the proper data collection. So if I don't have data, it's very simple. I cannot do data analytics, and I cannot do data science, and all of this nice talks will not be really feasible. So the first challenge that we meet is we would like to innovate in the smart cities area. Smart city is a concept that is very large. It starts with a smart building, then it goes to a smart district, and then a smart city. So everything that was mentioned during the day, smart parking system, smart lighting, smart grid, smart usage of electricity, water, sewerage system, alerting you, for example, the traffic, where are the bottlenecks, the accidents, predicting that because of an accident there will be delays at the airport arrivals. All of these relations and all of these data that you need to gather at a city level are really the element, the founding element of smart cities. Now, the biggest challenge is, where do I get my data from? It's very simple. If nobody is releasing the data, if nobody collecting the data, I really cannot improve. For example, there is such a bad traffic in Beirut. So we can all say, okay, the traffic in Beirut will always be bad, and we can never, solve it. And we can say, okay, where do we install the sensors? Where do we install the readers? And let's really find out the bottlenecks and try to really start with the bottlenecks. So there is always a way to start solving some problems in a smart way, other than just saying it's really a bad situation. Smart cities require so many elements. You really need governments to help you. You need really the public sector and the private sector to work together. That's the complexity in the part that I'm doing, is that we are a startup. So yes, we are a bunch of extremely motivated people. We work 24 hours a day. We have the best intentions of the world, and we really want to make our cities smarter, which means the citizens happier. The whole concept of the happiness index, happiness ministers, and happiness, a lot of talk about happiness programs comes from making your life more efficient, more productive, not wasting your time. So unless the government supports the initiative, unless the private and the public sector come together, we really cannot move forward. And we have chosen an area which is very complex, just in terms of the parties that have to, give you the buy-in and give you to release the data. And this is coming, of course, Dubai being the beacon in the region in such areas. They signed last year the data law, and they are starting now to collect data at city level via sensors throughout the whole city of Dubai, and they will be connected on something called the Dubai Cloud. And within 6 months to 1 year, all this data will be publicly available, which means that people like us, entrepreneurs, will be able just to connect and get to know everything that's happening in the city of Dubai. Temperature, humidity, changes, traffic, smog, fog, noise, sicknesses, anything, you name it, that can be sensed will be there on the cloud. So there is no more limit for innovations from there, because you can really take any data that you want at a city level, and we saw the simulation, what you can track at the city level is huge. Then, the only limit will be really in our imagination, but also in the platform that will collect the data. You need to extract the data, you need to clean it, and then you need to start processing it, and then produce some actionable insights. So we have done this part. We have built, if you want, the engine, which will collect the data, clean it, process it, analyze it, produce actionable insights. Now we're starting now to get the data finally. So I hope in a nutshell I explained the smart cities concept. It's a very, very engaging and a very amazing concept, and you can see the impact immediately on the citizens every day, on people's life. So it's really magic.
Yeah. Well, I really like the concept of the happiness index. If we could control it, we'll make sure everyone in the audience would be smiling. So I really like that concept. But I also, just to summarize your main thought, you're talking about you want access to data, you want access to city data, you want IoT and sensors around the cities so that you can be able to
to analyze them.
To analyze it and provide the services that Mark Illigent want to provide.
Exactly.
Do you agree, Siroon?
I agree from her point of view, but I don't know if you paid attention from the morning, no one brought up education. Big data and education, big gap.
Yeah.
Really, we don't know where to start.
Yeah.
Because when we talk
Tell
about
us
data
about it.
in education, we always think about test results. And test results are a bit too late to detect problems. So when it comes to education, really, there's a lot of work to be done. And unfortunately, we see some pockets of change here and there. We see some teachers pioneering and wanting to use technology. We also see schools who want to change, but they don't know what to do, where to start. So many of the schools, countries, cities, what they do is they dump heavy, expensive devices onto the schools, interactive whiteboards, which are not being used efficiently. It's because many of them forget the most important factor in the education, which are the teachers. Yes, our students are technology natives. They know how to use technology, but teachers don't. And one of the biggest challenges for any edtech is to actually have teachers buy in. So there needs to be a lot of support specifically from government and big companies and put focus on the teachers, because they really, teachers are key, and they waste a lot of time on paperwork and bureaucratic processes at the school level, like lesson planning and reporting, and they end up with no improvement when it comes to schools. So when we talk about big data in the schools, we have to start in a place where we do collect the data. Mm-hmm. So what we want to do at
So you're one step behind.
Yeah. Okay. What we want to do at Camp Kalima is improve Arabic literacy skills using machine learning and analytics. To be able to do that, we first need to collect the data. And by data, I don't mean the grades. I mean how much time the student is spending on homework. What are the new words they use this month? What new words they studied in class, and are they using it in their day-to-day homework and tests? To be able to do that, we need teachers who are able to use technology to be able to encourage the students to use the technology. So our challenges are a bit different. There is no data to access, so we have to first start collecting the data.
Yeah. That's very exciting, actually, the area that you're in, and very unique, Arabic learning platforms and being able to collect information and help the students throughout their learning journey and inform the teachers along the way. And
Arabic language is another challenge. It hasn't been properly parsed, and so we're building our tools from ground up.
I would call for Lubna.
I guess the main challenge in the area that I'm working in is kind of a mix of both challenges that were already just mentioned. So First of all, when you are collecting data on entrepreneurs who are also migrants or refugees or people in conflict zones, and are using technology to innovate in their communities and make their communities better, we might read every once in a while about someone doing that in the news and see some highlighted stories, but to actually have that data available in a kind of an organized manner, that doesn't exist. I've been, reviewing large amounts of literature in that field, and actually, even the data I find there's literally so far zero about our region. And so it is quite difficult to, first of all, there is no data available in an organized manner to be accessed. And to add to that, there's also kind of a resistance to share the data from the community perspective. People don't really want to talk about this. The people who have these issues, the people who are kind of trying hard to kind of make that change in their community or start their business or whatever, most of them kind of want to leave their misery behind and not really talk about what's motivating them to do their work and what are the challenges they are facing. And the ones who really try to talk about this are the ones who come from a standpoint where most of them haven't really experienced that themselves, and you end up hearing kind of skewed perspectives. Yeah. So it's quite challenging to, even when you get data, to get data that's accurate. And to add to that, there's also the nonprofit sector in general, combined with the policy or the government sectors in. So I'm doing my study in different locations, which involve Berlin and Beirut, and soon Damascus, but that's going to take some time. Like to get to the civil society organizations or the NGOs or the local policymakers, to get them to collaborate with you on such projects is also quite difficult. Yeah.
So it's a change in mindset as well to share.
Absolutely. The cultural change involved is more difficult than using tools to analyze the data you will collect down the road.
I wanted to ask Priscilla. So when you came about to start leveraging data science, and we want to hear a little bit more about Caroline, who's only 2 months old, and we want Caroline to grow fast. Your organization or your entrepreneurial small team wanted to make a decision whether they pick an off-the-shelf tool or they do their own coding and their own tool themselves. When you made this decision, which one did you go to? And I'm mostly speaking for people who want to go into this space and be able to leverage the tools outside. And what, from your perspectives, are the pros and cons of picking each one of these two routes?
Okay, great. So my field with Caroline is artificial intelligence. And a big thing with artificial intelligence is the humanization of artificial intelligence. So when we talk about data collection is really important in respect to that aspect. Now, what is Caroline? Because you guys still don't know what Caroline is. She is a lead generation and engagement bot. So she listens to active conversations online to the keywords that we ask her to listen to. So for example, in the case of my key, I might input password. And as soon as somebody mentions the password online, Caroline will flag the post, profile the user, and tweet, depending on a series of answers, to get them to actually sign up and use the product. Yes, so that is a lot of data, Asma. Asma's crying. Okay, yes, a lot of data, a lot of data. So what are the pros and cons of using? Caroline was built from scratch. But what we do use, for example, is Slack. So we speak to Caroline through Slack. Slack is the portal through which Caroline displays the information to us and allows the team to interact with her. What are the pros of actually customizing your own product? When you customize your product, you do it exactly how you want it. So building from scratch, customization, that is really important. You're doing it to the T. But again, using off-the-shelf tools, that's just good sense. Why? Because you're using a robust system that works. So you can come, experiment, iterate, test. We could potentially build our own portal to speak to Caroline. But today we use Slack. It allows us to immediately understand what it is that we need, really put it forward, test and iterate quickly, and move forward from that.
Excellent. How about Fadwa? What did you guys consider doing?
I totally agree with Priscilla. the wisest and the least painful way is really to start with available solutions. I mean, there is so many on the, you have IBM has a Pro Watson and IoT, and then all the big guys. Microsoft has an IoT platform. All of the big guys have an IoT platform for free. So I would say that, yes, the wise thing is to use what is available. You test it, you do your dry runs, you do your whatever is available. And this is what we did when we did our MVP, when we launched our minimum viable product. It means that we built a very, very quick smart city platform that was not destined for big data. It was just really destined for a very, very small data. But we showed it to all our clients. We took feedback, and we definitely used what's available off the shelf. Now, moving forward, we definitely would go for building everything the way we want it, and the only way is to build it in-house. If you really want your platform, your engine to perform the way you want it, you have to build it in-house. But I would not advise it in the first stage unless you really know 100% what you want and what you're going for. Start with something free available. As you get knowledge of your product, and as the product matures, then build it from bottom up or top down, as you like, but just build it yourself later on. Because the degree of customization, the algorithms that are needed to do your machine learning, your artificial intelligence, everything that you need later on, you have to really know the formulas you're doing. You have to know what the problem you're asking. You have to know how you are seeking the answer to that problem, what biases you are introducing, how did we come up to this conclusion? Because your conclusion can be very wrong if your training set is full of biases. I mean, the example given earlier in the day when only Google, I mean, imagine a giant like Google has only shown white faces to a human algorithm. And then when a black person was shown, it was identified as a non-human. And I'm talking about the giants. So let alone people with less force that can introduce so many biases. It means that your training data, what you give to the machine to learn from, could be full of the wrong conclusion. And your biases will be inherent in the conclusion that you give. So if you use something off the shelf, yes, it's robust, she's right. Yes, it's quick, but you definitely don't know later on what biases you have introduced. So I would say really build it up at a later stage, and you know at least what you're doing.
Stepping stone. So do you agree as well, Cyril? So we build a minimum viable product with a product off the shelf, and then once we're ready, we go back and start from scratch?
Exactly.
Right? Is this what you tell me?
Yeah.
Okay, great. So I wanted to also ask Lubna, so if for your business, if you're trying to look for an ideal data scientist, what would that profile look like? You've got a lot of students, some of them may be looking for jobs, and they might want to say, okay, if I want to be a data scientist, I'm doing computer science, what else do I need to do,
Well, I'm going to talk about it from the non-technical perspective, because if you look at the backgrounds of maybe all of us here, maybe only one of us is an engineer here, right? And so just really do something you're passionate about. I think one issue we have is that, and that's one issue I see both in the engineering and the startup scene, and maybe especially the tech startup, which mixes both together. We have a lot of people becoming entrepreneurs just because it's the cool thing to do. And also a lot of people, everyone is a CEO and founder these days. It's like such a common word that I'm like, I mean, you just made this, okay, that's a separate topic, but a lot of people, I'm looking at what they're doing, it's like, I would not call myself a CEO if I were in that person's shoes. You also have a lot of people going into engineering or, going into advanced analytics in general because we're also a society that encourages us to either be engineers or doctors to be acceptable. Just really look down deep into it and make sure that what you're doing is driven by different reasons than just what your parents really think you should do, or because what everyone else around you thinks is cool to do. Do it because you believe in the real value of what you're doing, and do something that has the potential of making a positive impact that would also make you feel good about yourself at the end of the day.
So Siron?
Okay, also to put aside this working? I didn't do anything.
Microphone here, please.
Hello? Yes, no?
It's back.
It's okay, I'm a teacher, I can speak without so when it comes to education, I agree with Lubna. Math and science may be important for data scientists, but it goes way beyond that. Specifically when it comes to different fields. So, for example, if someone wants to work for Kamkalima, and we might need a data scientist in a year or two, we would like that person to know about education, about K-12 education, about social behavior of students, about the problems students face, maybe have taught in a school for a year or two. Apart from that, they should know to ask the good questions. It's not just analyzing the data, it's also, there's mountains of data, but how do you make sense of it? You know, asking the right questions, being curious, thinking outside the box, and specifically when it comes to data, being ethical. It's extremely important.
So knowledge of the industry, right? In your case, knowledge of the industry, definitely.
Yes, definitely.
You know, being ethical and insightful, right? And I think in your end, you know, really have a genuine interest in what you're doing.
Absolutely.
Just don't go in it just because everybody's in it.
And you know, sometimes you might be forced into a situation where, yeah, okay, fine, I've been just doing this for a while, or I chose this major already, and I'm already in that field, and I don't like it, but I'm just in it.
Yeah.
At least start, okay, make the best out of what you have, because when you have so much, when you are developing skills, particularly in this field, particularly in the combination of starting something new, starting a new company, and bringing the technology and data science element in, this is going to change the world. This is changing the world. And just think about how exciting it is that you are part of it. Yeah. And just choose an application as part of that world of entrepreneurship and data science that can actually kind of satisfy a need that your community has or that you have, or something that can resonate with you personally. Don't just do it because you have to do it.
Thank you. And, you know, I want an additional perspective. If I may ask of Fadwa?
I mean, just like the definition
we need to build this unicorn. It's a unicorn, right? We need to build it. So let's add.
It's just like the definition of what's a data scientist itself. If you just look it up or you try to see what's written over there, it's really very, very depressive. So you have to have a PhD in statistics. You have to be a very solid mathematician. You have to have a solid coding skills, and then you have to have the domain expertise. So imagine a person today that we can pick, you know, that who would be a PhD coder and domain expert. I mean, really, it's, I mean, personally, I don't know such a person. I mean, very few really in the world can match this. So I don't want just, if you take the textbook definition, I mean, I'm really referring to something very solid definition. I mean, earlier in the day, we spoke about the soft skills and the hard skills and the T and everything, which is fine. But to build the T that the doctor in Canada was talking about, I don't want you just to feel that it can happen in a second. This is really a very, I mean, a very long process, and it's worth it, definitely, to do it long process. The way we've done it is really to work in teams. I mean, I have the mathematician, I have the statistician, and I have the domain expert. And it's, by the time each one of them had the three, it will take time. So what we did is really, we work in groups. So the three people work together, they discuss together, and this person is able to do the formula, the other person is able to do it in R, in Python. The third person really knows what's the domain. But most importantly, those three people have to get out of the office and go and see what's the problem. And if you really want to ask me about a real data scientist today, I will tell you he's not the person that we depict in you know, in comic books or in movies, just sitting behind the PC and just doing, you know, this number crunching and everything. No, a data scientist, the real one, he has to get out of the office and go talk to the people responsible for the problem he's solving. If he's solving a retail problem, he has to be in the mall. He has to speak to merchants, to buyers, to consumers, to the janitors, to the people who lock the mall, who open the mall. He has really to understand the whole journeys of what's happening in a mall. So putting the whole customer journeys and talking to people and then going back to the office and then putting this into math and statistics and what is the right question. For me, really, this was the most rewarding approach, because otherwise you end up with results that has nothing to do with what's really happening in the problem you're solving. So an ideal data scientist, if you have the three of them, statistics, math, and coding, and domain expertise, you really got the jewel, and never give up on this person. But if you don't find this person, just put a team together and work from there on this. So it will be your team of data, rather than one person.
Thank you. That's reassuring. So you can put a team together rather than have all these qualities in one person. So that's good. I'm not finding shortcuts here, but I think it's a nice option to have, to put a team together. So I don't want to be asking all the questions, so I would like to open it up to the audience and be able to take some questions, I guess, on Twitter, if there are any. So I'm going to head this way. So any questions?
We have a few questions, Fida.
Sure.
To help our cities today become smarter and start benefiting from these technologies that you have developed?
Very good question. For example, I have my work relies a lot on sensors, and I do a lot of readings from sensors that we install to capture a certain data with certain, the 4 V's, at certain intervals and everything. The first input that I can get from anybody is really through your smartphones. Your smartphones is the most powerful PC ever created, and it has so much readings. It has a GPS inside. It has the level of movement that you're doing, if you're sitting, if you're moving, and there is so much data even in your mobile. So let's say if we were to run some data collection through your mobile and we explain exactly what we're doing and why we're doing it, this would help a lot just for people. Now you will come always with the issue of security and safety and all of this. Now, if you ask me, really my opinion, the biggest data breach that happened last year, this distributed denial of service, DDoS, that happened last year, and it has knocked off Twitter, if you remember, it happened through IoT. So the use of all these devices that turned into an army of just sending so much requests to the provider that it had collapsed. If you tell me, is IoT 100% safe today, I will tell you, of course not. And it's not supposed to be safe where we are today where we are with the development of IoT. If you ask me, does this DDoS, denial of service, will happen again? I'm sure 100% is going to happen again. It's going to be more ferocious than the first time. But the good side of it is that we're learning. So when it happened the first time, there are now so many algorithms and so many systems put in place so that it doesn't happen. Now, there will be another breach, I'm sure, and then we will learn. And I think this is a process which is, unless we're able to stop hacking altogether, and I don't believe it's going to happen anytime soon, I think it's a learning process today. So the market is developing IoT products, sensors, and readers, and there is a lot of breaches, but it's only a learning process for the next at least 4 or 5 years.
Yeah, my question is concerning education. So to Ms. Siroun or anyone else who can contribute. My question is, when you want to collect data on children to improve education, how would you go about it, and how far would machine learning and artificial intelligence would go, to which extent to achieve that? Because it's a big issue in education and schools nowadays, and how the use of children on social media can be very upsetting for parents or can be compromising. So I think it's so many questions in one question. So please, thank you.
So there are a lot of issues, of course, and that's, I think, one of the reasons that big data and education is falling behind. Big data in education does not mean student social media. On the contrary, a good education platform should not collect anything from the student, not even their email addresses. What I mean, the type of data sets that we should be collecting at the first stage would be type of mistakes they do, type of times they're trying to do an assignment or a type of homework, the number of, and the progression. So month after month, are they improving, are they changing, so that we pinpoint the problem before the formative test. Because once the test is there, it's too late for an intervention. Of course, there are so many other data. So for example, in Silicon Valley, there's Alt School. I don't know if any of you have heard of it. Alt School, it's being funded by Facebook, but what they're doing is a bit scary. So they have cameras all over the school. They have facial recognition devices all over the school. They have heart rate monitors on the students.
Smart school.
They're totally smart school. They collect all these data, hoping that one day they will understand even the emotional impact. What I personally think that's a bit too far at this stage. Let's start first, by collecting the data that's not personalized.
Anonymous.
Even from teachers. For example, if I'm an education institution and I want to do professional training, how do I know what type of professional training do I need to do if I don't have the data? That's why lots of professional departments at school are not doing such a great job. And it's not because they're not trying, it's because they don't have enough data on teacher performance to be able to do it. And unfortunately, teacher performance is based on test results. And the loop goes on and on. So imagine if you have enough data, even university remedial courses will be targeted. Professional development will be targeted. The big term in education now is differentiated education, and schools come and dump it on teachers. They say, okay, 21st century learning skills requires you to do differentiated education. A teacher has 30, 35 students in class. How's she going to differentiate if she doesn't know what each student's problem is? Data can make that very simple.
That's great. So leveraging data to really customize the education for
without personalizing the data. And of course, the problem here will be third-party vendors like Kamkalima. We should have maybe governments also should put regulations on education vendors. Data should never be sold to marketing agencies, third-party vendors. It's imagine students be targeted by advertising because third-party edtech companies sold the data. So at the policy level, government should also put some, because right now we're putting our own
rules and regulations.
Yeah, of course.
Data
our
governance.
own privacy policy.
And privacy.
Yeah.
Okay, I would like to take one
well,
more question.
I was thinking of a question that could cut across all the speakers. You mentioned that we might have so many engineers, doctors. We need cities, we need education. And I would like to ask you all, how can we build a data science platform to guide the future generation on needed skills for cities, for government, and so on? And this will address the question of having too many engineers and scarce skills in some area. This does not need government. It requires just scanning of the various media and then field them in field. And so if you could be doing contribution to the world, what can you think of this?
Yeah, I think that would be a great idea for people in the audience who are thinking about starting their own businesses. Dr. Osman is saying that potentially we can have a business that identifies the skill set needed for jobs, and maybe that will be a great input for us universities as we put together our curriculum and then help these students get ready to the real world. Great question. Thank you.
No, I like the idea. I mean, it's like a job description optimization platform or something. Teach HR departments how to create the optimal, job descriptions for a particular job. You might be asking for too little or too much skills when you need specific kinds of skills that can be enough. And I like it. I might need to pitch this to at some point.
Might steal it. I think that within an educational context, especially within universities, there's a big responsibility for universities to actually drive students within, even before they get to university, driving them and orienting them into the fields of the future. So once we really have enough information on the trends of what's happening, then this is where, a couple of years ago, everybody started going into coding. Why? Because we understood that this is where the trend is going. So it's important for educational institutions to stay on top of the trend and gear and guide the students in the right way.
Yeah, and it's educational students, and it's the students themselves too. So I think
yes, absolutely.
It's the two sides of the coin. It helps calibrate, the resources.
Yes, and then it diminishes from having an excess of lawyers when we don't need, an excess of lawyers or whatever it is. Just really specific. Yes.
So I wanted to ask Tariq if we had any online questions from our online community to the panelists.
So the people tuning in via our live stream are addressing some questions to our panelists. The first one is addressed to Priscilla by an MJY. What differentiates Caroline from other bots that are out there like Siri or Cleverbot?
Okay, so I think any differentiator is the value proposition. The more you're specific about what it is that you're creating, the better it is. I mean, Siri, she can give you answers, probably superficial answers related to a couple of things. Caroline is feeding off specific data related to certain parameters that you're feeding her. So if your startup, let's say you have a startup, were to actually take Caroline, you could go ahead and input and say, I want Caroline to listen to the following 5 words online. I want her to profile people based on these specific parameters. So customization is key with Caroline, and it's cross-industry. So it can allow any company to benefit from super specific targeting.
Thank you on behalf of MJY. Another question directed to the panel: how to deal with security concerning smart cities and homes?
I was talking about this earlier. I definitely think there will be some serious security attacks this year.
Thanks.
So I'm really telling you.
So is that data-driven prediction or?
No, it's just like the way the system has been built. It is inherent for this type of attacks. So yes, we will close some doors, other doors will be open, and hackers are very good at detecting always the doors in any IoT system. So if your house has already everything, a garage and a thermostat and everything, the AC and the door and the intrusion alarm and fire alarm and all of these are connected together. If you have some old equipment with some new equipment, it might be that some of the equipments are not extremely well closed, and there will be some interoperability issue, but there will be also some doors. So I really think that we will have some attacks. I think it's part of the system, and I don't think we should overreact every time it happens. So we just build a better system every time. We learn from it, and we get better systems out there. For the time being, there is no other way than actually doing it every time and learning every time.
Okay. Well, wonderful. I wanted to thank you, panelists, for an amazing contribution. I wanted to thank the audience for all the great questions you had. And, I think we'll adjourn this panel discussion. So we'll go ahead and, are we taking a break now or no? Yeah? We'll go ahead and take a 15-minute break so we can continue our discussions outside.
Thank you, everyone.
Thank you, Fida. Thank you. Thank you so much for the great moderation. Thank you.
Well done, everybody.
Thank you. Thank you, Sirwan.
Thank you. Thank you very much. Thank you very much. Thank you. Yeah.
So we're starting our next track, applications of data science in business and finance. Moderated by Dr. Lina Daou-Oiri. Lina is an assistant professor of organizational psychology at OSB and the director of the evidence-based healthcare management unit at AUB's Faculty of Medicine. She specializes in psychometrics and recently developed the first model of personality for the Arab world, a groundbreaking research that our region is definitely in need of. Lina also applies her knowledge on organizational psychology and psychometrics to better understand doctors, nurses, administrators, and employees working in hospital settings. Lina's work has been published in leading journals across multiple fields, which reflects her interdisciplinary research interests.
Thank you, Lama. We shouldn't have had this break. You've had a break not long ago. I think we should have just continued, but I think more people will be coming in. But I'm going to start introducing our first speaker. But before I do that, I would just like to, first of all, tell you that this is the last Tech Talk for today. It's an absolute honor and pleasure to be part of this event. Thank you, Lama and Fida, for inviting me and thinking of me. I am here not because I'm a researcher and I'm a scientist. I'm not a big data scientist, but I am a scientist nonetheless. But I am here today as a woman who wants to stand here and celebrate women and the role, the incredible role that they are playing in changing the business world and everything in multiple industries. Today I have 4 guest speakers that I will be introducing. I wish all the other speakers were there because they deserve a massive applause. I learned so much today, honestly, about so many topics, but you know, I think I've never felt so proud. It's been such a long time since I felt so proud. Anyway, so I have 4 speakers that I will be introducing. But they're going to be giving 3 talks. So the last 2 speakers are co-panelists. The first speaker is Dr. Nadia Masoud. Dr. Masoud joins us from Melbourne University, Melbourne Business Schools in specific, where she is the Ian Potter Chair Professor of Finance and Associate Dean of Research. Dr. Masoud completed her PhD in Economics and Finance at Queen's University. And then she held an associate professor positions at the University of Alberta and York University Suliman School of Business. Did I pronounce it right this time? Dr. Masoud's research has received extensive awards and appeared in leading journals, some of which are Journal of Financial and Qualitative Analysis, Journal of Finance, Journal of Financial Economics, to just name a few. But her research mainly focuses on corporate governance and regulation in the banking sector. Ladies and gentlemen, please welcome Dr. Masoud.
Thank you very much, Lina. Just me upload my slides. Where are they? Well, first of all, I would like to thank the organizer, Lama and Fida. You're doing amazingly well. You organized an amazing conference with a good line of presenters that make all of us proud. We know, like all of us, like women representation in many disciplines is really low, and as women in the Middle East as well, we should help women appearance in different disciplines and involvement, and this is one of the great initiatives. The previous panel put a very good stepstone for this session. We are moving from sciences towards human education and human research. So today I'm going to speak to you a little bit different than what we started with. It doesn't mean it's completely different. We are using similar tools and similar techniques, but we are starting the starting point a little bit different. Let me show you how I am different than the previous presenters, amazing presenters. So my field, as mentioned, is based on banking, financial intermediaries, and regulators. Before I start my own research, let me show you a holistic view of our discipline, or my discipline in particular. So we are looking at big data and financial intermediaries, big data collected from different fields in the financial intermediaries. For example, we have data from regulation and compliances for financial intermediaries. We have many million of data for customer data. Transaction data can come from retail and wholesale. And we have data from risk management. And as you may know, financial intermediaries include many types of financial intermediaries. We have asset management. Asset management, we have it to private, like hedge funds, and we have, for example, a mutual fund, and we have pension fund who basically manage our retirement. We have banking, commercial and retail, capital markets, and insurance. Big data are being continuously collected through different transactions. Those transactions can be related to pricing, operational data, and for example, operational data can be from order activities. So today, I'm gonna talk about the small red area. I'm gonna try to conduct all of those areas to show you how I use big data in my own research. We have a problem in finance. The problem in finance, the data collected intensively in different parts of financial intermediaries, but this data not connected. Similar problem that Lubna mentioned in her field, zero data. We have some data, but unfortunately the data not connected together, or because of a privacy issue, this data is not available for everyone. As a researcher, this is a challenge for us because we want to address and solve problem in the financial industry, but at the same time, we don't have data to actually solve those questions. And this is how we are innovative in my research with my group. I have a team of researchers that work with me, PhD students and colleagues, to uncover or answer those questions. And if you know, I think most of you, and unfortunately, the financial industry is not very popular these days, especially after the financial crisis. Unfortunately, ethics is not working very well. Illegal activity is very common. Market manipulation happening very frequently, and it's a big nightmare for regulators. And my research actually linked to those issues. For example, we have, after the financial crisis, there was market manipulation with LIBOR. LIBOR is the kind of interest rate for borrowing and lending at a higher level, at a wholesale level. And also there is some problem with the foreign exchange. There is some market manipulation in those two sectors where actually it's done and used on a daily basis among large players like banks and other financial institutions. Regulatory bodies try to collect data and encourage for data collection to increase the transparency in this sector. So following the lead of those researchers, we are trying to address in our research with my group, market manipulation. So the data, as I said, not available, and our innovation is to answer important questions by connecting a source of data from here and there and try to find out or resolve some stories. So my work with my PhD students and colleagues motivated by this Business Week article. This Business Week article basically addressed an issue for one of the companies. This is Movie Gallery. It's a big company with the videos. Borrowed fund from financial intermediaries. This financial intermediaries, usually you borrow fund from a bank. You need to buy a car as an individual. You go to the bank and fund your car. For a firm with billions of dollars of need of fund, they cannot borrow this millions of funds from just one bank. Sometimes they borrow it as a syndicate. We call it syndicate loan, where a group of lenders get together and lend this company the amount of fund they need to fund their projects. Unfortunately for this company, the group of syndicates, they were not banks, they were mostly hedge funds. Hedge funds, they are aggressive in the market, they want to make money, and their objective also to achieve target of making return higher than what the market is making. So they have to be innovative in their investment strategies. So those hedge funds, so in other words, their objective function little bit different than a bank. A bank, they want to maximize the profit, but over a long term. For a hedge fund, sure, they want to maximize the profit, but they want to hit and run. They are short-term profit maximizers. In other words, they're willing to do anything to achieve their targets. So after they borrowed from those group of hedge funds, movie gallery, they have problems. They have financial problems. The financial problems not revealed to the market directly. It was discussed among the management team, and they called the borrowers to help them to reorganize the loan. So after the hedge fund called to reorganize the loan, they accepted. This was done in March 6. After that, the lender accepted to amend the loan, and they changed the term of the loan by increasing the interest rate and by increasing also the amount of loan. After then this is when the announcement went to the market. Now everybody knows this information about movie gallery. Let me show you what happened to the movie gallery shares. This is the short selling. Are you familiar with the short selling concept? You are. So short selling, basically, when you sell something you don't own. You borrow it from your neighbors and you sell it. And the objective is to sell it to somebody really low, and in the future, to sell it really high and buy it really low. And you make the profit between the difference in the prices, okay? So this is the short selling activities for movie gallery prior to this announcement. So the price, for example, when they called the hedge fund was 3.27. And this is when it went to the public announcement, the price dropped to 2.28. So you made almost $1 over 11 days. Okay? So this is potentially what you could make. And if you look at the short selling activity, just after the announcement, just after the meeting for renegotiating the loan, look at the spike in the short selling. So basically, the short selling was really low, and suddenly the short selling increased. And what happened? When the information revealed to the market, the share price dropped. In other words, if you short sold within this period, you could make lots of profit. Now the question is, does this behavior is it related to all loans or average loans that lent by hedge funds? We consider this action as market manipulation because you are actually trading on a private information before it's revealed to the market. So we want to investigate whether this kind of activities happen very frequently in the market. And this is what we done in our research. So what we did, we collected data on short selling. We have the data for short selling, but we don't have the identity of the short seller. So in other words, we want to back out the behavior from the data itself. So what we did, we combined this large database, which I showed you before. This is the kind of data produced by financial intermediary. We combined it by 6 other databases. So we need also database about loans, syndicate loans. So we have to look also when those loans actually get renegotiated. We have to do textual analysis. And also we need to understand in which loan the hedge funds are involved in. So we have to match the name of the hedge fund with the loan item and the name of the firm as well. So we have a firm and many lenders. We have borrowers and lenders, and we have to match all of those databases together. And the short selling data will be matched at the firm level. So in total, we have this large database, and in that way, we will be able to see the behavior, whether if the loan extended by hedge fund will be different than the loan extended by banks. So what we did, so we formed two groups. We group of loans that initiated by hedge fund and a group of loans that initiated only by banks. So the treated sample is the hedge fund, and the match sample will be the bank. And look at the short selling activities around the loan, actually, just prior to the loan renegotiation or the loan initiation, and look if there is different pattern of behavior in short selling activities. As I said, short selling activity, if there is a spike prior to the announcement of loan negotiation or initiation, this is indication of market manipulation. And sure enough, we found a very big difference in pattern between hedge fund and banks. So this is one aspect of it, where we have the treatment and the matching sample. And then we looked at the severity. If the amendment in the loan, similar to movie gallery, was penalizing, it became more expensive, or it's more favorable, whether we see difference in the short selling. And actually, yes, we see difference in the short selling. The short selling is more severe. In other words, market manipulation is more severe when the amendment is basically not favorable for the firm. While when we compare for the banks, it's not the same. So this is basically how we use big data in helping our understanding in market manipulation. So in conclusion, what we found hedge fund using this big data more likely to make loans to risky borrowers because they are more short-term profit maximizers. And we showed proof that hedge funds are more likely, not every hedge funds, but on average, hedge funds are more likely to use this data as a source of creating more profit and taking advantage of the borrower. In other words, what we noticed is that the short selling is more likely to happen when hedge funds are involved in the loan. This raises very important regulatory issues with hedge fund involvement in the loan industry. It was previously dedicated to the banks, not to hedge fund. In other words, long-term profit maximizer over short-term opportunistic profit making. Thank you very much.
Thank you very much. I'll ask you to come back again when all the talks have finished so we can have the Q&A at the end. You know, when I was standing outside, I heard gentlemen ask, I work in data science, why don't they interview me as well? I have a lot to talk about too. Which is great and fantastic, but you know, I would like to see this gentleman again, to tell him that, you know, women in the business world have an issue. There's 56% approximately of university graduates are women, but you know what's the percentage of women represented in the workplace? Around the 20%, 22, that's in our country. So we have this issue, and then there's another issue of stereotype that women, there are certain jobs that they do and other jobs that are smarter and science-based, etc. They're not for women, they're typically men do these things. So today, the reason why we're interviewing women and we want to interview and we want to bring in more women to talk about their data science and their work is because we want to start breaking those stereotypes. Women are working and doing equally challenging jobs and equally interesting work. And now I want to introduce our next speaker who will tell you about her work as well. Her name is Dr. Ghida Ibrahim. She's a senior data scientist at Liberty Global in the Netherlands. She has approximately 6 years experience in operational and research experience actually in data science and ICT engineering. She graduated from Telecom Paris Tech in France. And she now works, as I said, in Amsterdam, where she uses the company's data for understanding customer churn, enabling predictive network maintenance, and recommending TV programs and videos to consumers. So if you're wondering who's actually, how does all the Netflix, for example, know what you like and keeps on pushing it towards you, I think we have someone to blame here. Please, Dr. Ibrahim, if you can come and tell us all about it.
Hello, everyone. I'm very happy to be here. Thank you for staying till this late time of the day. It has been a long day. So yeah, I'm Gida. I work for a company called Liberty Global in Amsterdam. Just like an introduction about Liberty Global, because I'm sure that like most of you haven't heard about this company. So Liberty Global is an international TV and broadband company with operation in 30 countries, mainly in Europe and Latin America and the Caribbean, and our main operations is in Europe. And today I'm going to speak about how to build recommender systems for TV and video products. So what is recommendation? As surfers of the internet, I'm sure you came across different forms of recommendation like every day. And like the most famous form is YouTube. I listen to YouTube all the time while working. I can focus and listen to YouTube at the same time. And usually YouTube like recommend to me like new videos to see based on a number of criteria. And like most of the time, we really don't know what are these criteria. We have the feeling that it's related to what we have seen before, but sometimes it's new things. So we don't really understand how it's happening. And I was curious personally about it. This is why like I started studying recommender systems, and I'm happy to be building now recommender systems. So recommendation, very like high level, is an intelligent operation that allows you to see this in your YouTube feed, or this in your Goodreads account, or this in your like LinkedIn account, suggestion of connections, and also on your Facebook account, and basically on every website you go to, you will find this kind of recommendation. So how does it work? Actually, there are like many techniques used for building recommendation. I will list a few of them. This is, of course, like not a full list. It's like the main, most known techniques in the industry. So the first technique is using metadata, which I think like many people, like many speakers today talked about metadata. It's data about data. It explains a lot about items, about people as well. And like one metadata is users metadata. For instance, if we have two persons, Amanda and Sarah, and Amanda is 26 years old, British expat, living in Amsterdam and working in the banking industry. So this is basically the profile of my roommate. And we have another person, like Sarah, is also 27 years old, British expat living in Amsterdam and working in the banking industry. So if we do know, or a website knows this information about these two people, Amanda and Sarah, they will notice that there is a lot of similarity between these two people, and they will conclude that probably Amanda's preferred choices will be also like appreciated by Sarah, whether these choices are videos or books or also connections. But like in true life, this is not exactly true, because even if you and your cousin like look like each other, have the same age, grew up in the same family, you end up doing like having many different choices in life, professional life, personal life. So like research has shown that this kind of technique is not very accurate. But still it's used, and it was used at some point. It was like a large part of the state of the art, I would say, and it still exists in the state of the art today. Another form of metadata is items metadata. And yeah, I chose these two like films randomly because they are both relatively long films, and they feature the same main actor. And like in both films, it's a bone-chilling experience. At least this was my impression when I went out of both films. So yeah, maybe this kind of suggestion would be given to user, even though like these films went out at different times, at different years. There's like an important years gap between the two. So it could be that we recommend The Revenant to people who have lately seen Titanic and vice versa. Another technique which is more widely used today, and I think one of the speakers talked about collaborative filtering without really like explaining it in depth, so I'm happy to explain it a little bit deeper. So collaborative filtering is basically making predictions about the interests of a given user or the preferences of a given user by collecting preferences and behavior information from many users, including users that may not be in the social network or in the professional network or in any even geographic network of this user. So basically making predictions about your preferences based on your preferences, but also the preferences of other people and the behaviors of other people that you actually may not know. So for instance, if you have seen The Beautiful Mind, The Theory of Everything, and The Imitation Game, and another person have seen 2 of these, probably these 2 persons are kind of similar in some way, even though they can be of different gender, of different age range, and therefore like what you have seen and this person has not seen will be recommended to this person. So how do we build the recommender system, especially like in the context of my work? So as I said, I work for Liberty Global, which is an international TV and broadband company. We have some kind of data that we call viewership data. So basically, it shows what people have seen on their TV screen. And what we have in the data set that I based my, let's say, I built the recommender system based on this data set is 10 billion sessions generated by over 1,200,000 unique users. So this means that we may have different users generating different sessions. It shows what Liberty Global customers have viewed on their TV in 2016. So it's like 1 year long data. And we have like 2% of the data is over-the-top devices, so basically mobile phone and tablets, but it's really not very representative. It's a small chunk of the data and a lot of missing information in it, so we just discard this part for the time being. And viewed sessions are divided as follows, so we can see that we have 3 countries, with the Netherlands as a major country, and Ireland and Switzerland. And also we have different types of content that is being viewed live, video on demand, and replay and time shift. And as you can see, like live is the largest proportion of content that is being viewed here. So how did we build the recommender system? Basically, we transformed and amended this initial viewership database. We built a first recommender system using collaborative filtering that I just explained and based on viewership data. We built a second recommender using collaborative filtering and based on rating data, and we assessed a recommender system's performance. So, as I said, we have the viewership data, but also the viewership data includes like many numbers that are not representative of anything. For instance, let's say the gender is designed as 1, and 1 may mean male and 2 may mean female, but we really like need to transform all this data from like numbers into something that can speak to a data scientist when they are doing their job. So basically the first part involved a lot of data cleaning and data merging and data subtraction in order at the end of the day to build a new matrix that is actually the combination and the filtering of many matrices that were merged together. And as you can see in this matrix, we have like 10 billion sessions, 12 columns, variables. Each of them refers to some kind of like metric or information or KPI, I would say, that is of importance for our work later on building the recommender system itself. For instance, we have the viewership start, and as you can see, we have the date, we have the time, the hour included, so this is also important, the viewership duration, the session type, the platform type, so we have like different kind of setup boxes or machines that are placed at home that the users have, and they have different names, and one of the machines is called Horizon. We have different subscriber ID that refer to a given subscriber, gender, birth date, content gender, subscriber country, channel name, and also we have the CRID. So the CRID is the equivalent of the URL that we find on the internet. So it's the content reference identifier. So in the first recommender system that we built, basically, we built it solely based on viewership data. So what we have done is from this large data frame that we have built, we selected the user ID and the program ID. And then for each user, we put together all the unique program IDs that correspond to what this user has seen during the last 2 months. And for each given user with a given set of program that he has seen, we calculate the length of the intersection between these programs and the programs seen by each other users. And based on it, we compute like the best neighbors or the top neighbors for this user. So basically, these are the users that have seen the most similar programs or that have the highest overlap in terms of same unique programs with these users. And we recommend to this user the unique program that has been seen by his or her top neighbors, but have not been seen by him or her. And we fine-tune our recommendation based on the time of the day. So if we see that some program is mainly seen during the evening time, we don't recommend it on the daytime, and so on and so forth. Another method is based on rating data. So rating data, usually, like when you rate a film, we have this data, but in this case, I didn't have this data set, so I had to come up with a rating data. So we don't have, so this data set, the rating that we do in terms of stars, from like 1 star to 5 stars, is called EMDB rating. We didn't have it. It is not representative of users' behaviors and real impression, because sometimes just do the rating to just move to something else. It's not always representative of what you have felt about the film. Sometimes you see the same film and you say it's not a good film, but you continue seeing it. So sometimes we lie about what we feel, and what we see in reality is more representative of our impression regarding this film. So we built our own rating metrics from the viewership data based on a mix of viewership frequency and duration. So basically, if a user has seen a given film many times, this means that this film has a high rating. And if it has seen this film for a long time, this also means that it's also like a good rating. And here the rating is between 0 and 1. So basically, we have the ratings of by user U of item E, and we need to predict the rating of other users for items that they haven't seen. And basically, based on this predicted rating, we can recommend to these users these films or not. So basically, we need to fill these cells. So we built a second recommender system based on the rating data. So as you can see, we still use the notion of similarity, but instead of calculating similarity as a kind of overlap, we calculated more through this formula, which is based on like the ratings that we have calculated, so based on numerical and not like the films themselves. It's more on the rating of the film that we have calculated. And as I said, we calculate first the similarity, and from the similarity between users, we see for each user which are the most similar users, and we predict the preference using also this formula. And for each user, we recommend the items that are the most preferred or the highest with the highest preference. And how do we assess the performance of different recommender systems? So we do what is called A/B testing. And if we have a version A and a version B, so basically the portal or like the TV screen with different recommendations, what version of the TV screen would be generating more reactions from the user side? And in our case, our reaction would be more navigation, it would be more clicking and longer viewership. And this is how we compare how different recommender systems are performing. We are not yet at this stage. This is the coming phase. So yeah, this is pretty much my talk. If you have any questions, feel free to reach out. Thank you.
Thank you so much, Lida. We'll invite you again when we finish the last talk, actually, to get some more question and answers. I actually use YouTube quite a bit in my teaching in class, and every time I open YouTube, I get all sorts of Peppa Pig and SpongeBob and everything, thanks to Rida, because my son watches them all the time on my laptop, and now they recommend them to me all the time. Actually, there's one thing that I wanted to mention about Rida that is extremely interesting, and we didn't mention before. It's that Rida, actually, in her free time, on top of all this work that she's doing, she started Rafiki, which is an online platform for connecting refugees in Europe to volunteering mentors over there in Europe as well. This is fantastic, and I wish you all the best with this, and I hope many people are using it. So our next panelists, actually, they have a unique way of presenting. They're going to be co-presenting. Both of them are from Microsoft. I'm going to start with Ms. Rima Sem'an, who's a data scientist at Microsoft Gulf. Rima is an AUB graduate. Very happy to have you back here. And she is now cloud solution architect for Microsoft Gulf based in Dubai, UAE. As a business intelligence consultant, Rima brings crucial analytics to business solutions, and her job is to solve real-world business problems by building cubes She'll tell us more about it. Applying data mining algorithms and designing interactive analytical dashboards that enable business users to gain insight and take the right actions at the right time. Her co-presenter, Ms. Daniela Colombo, is the Advanced Analytics Specialist at Microsoft EMEA, so Europe and Middle East. She actually joined the Microsoft as a Mac MBA, and then now she joined the Global Black Belt team as a technology solutions professional covering advanced analytics. She focuses on identifying and developing customers' advanced analytics projects and help them to start and to accelerate their digital transformation. What you don't know about Daniela, or maybe you know if you read her bio, she actually competed in the Olympic Games in Athens in 2004. She was part of the Italian Olympic team for sailing. Did you win? Well, but you competed anyway. Please join us. Thank you. Please join me in welcoming our speakers.
Is that our session? Yeah.
Hello, everyone. Cool. Let me just say this as a start. It's the first time ever I enter a conference and I don't feel awkward in a room full of one gender type, let's say. I'm very proud to be here today and having this diversity across. Let me introduce myself my way. I am Rima Sam'an, a data architect from Microsoft Gulf. I help customers unlock insights in their data in various industries that we will walk through right now. I'll let Daniela introduce herself.
Hi, everybody, and thank you for inviting me. I'm Daniela Colombo. I'm focusing on advanced analytics, which means for Microsoft, machine learning and deep learning.
Cool. Will this work? Okay, perfect. So our topic today is going to be applied data science in the industries. We want to break the stereotype that data science in general and whoever works in data science are those introverts who work in the corner, who run machine and models, and nobody interacts with them. On the contrary, machine learning and data science and data analytics in general is very, very cool. And we're going to walk through all those scenarios that make it more cool. And we're going to just discuss what Microsoft is doing across the region and how are we enabling our customers eventually to apply data science across different industries. Just to put the frame for our presentation, business is being transformed in three major ways. The rise of big data. Big data now is everywhere. Data is being read from Internet of Things, from social media, from customer analytics, all kinds of information. The second is the maturity of cloud computing, which enables, crunching and slicing and dicing of this big data and applying machine learning and data science algorithms on top of it, which lead to the age and era of intelligence, and hence what they tag it nowadays as the fourth industrial revolution that we are in nowadays. So those three trends are shaping the industry, and they're tagging the industries and they're tagging the enterprises nowadays to be the intelligent enterprises. So there are a lot of studies that say actually, if those enterprises do not embrace this digital revolution or the fourth industrial revolution, they will be out of the market very, very soon. Why? For one main reason, because if those enterprises will only stay asking the questions of what happened and why did it happen, rather than what may happen or what will happen, and how do I think, for example, to generate what should happen or what shall I do next, then they will definitely be out of the business with all those categories that we will be talking about. Next, I will hand over to my colleague, Daniela.
So we want to take a little bit of step back because everybody was speaking about machine learning, deep learning, neural nets, but what are we really talking about? So first of all, machine learning is trying to solve some questions, answer some specific questions, and we can divide them in two main classes. The first one is supervised, which means that we are creating our model based on the ground truth. So we know exactly that you belong to class A or class B, which means answering a classification problem, or we know that given a specific behavior, we are out of this range, so we kind of facing an anomaly. This is a scenario, for example, for IoT, where we want to identify anomaly detection and do predictive maintenance. Or we have data to do some sort of forecasting, regression, which means how can I estimate how much and how many of my objects I'm going to sell within the next few months. But then it comes to, for example, clustering, which is an unsupervised technique. Because given the people listening to this speech, how many groups can we divide each other? That's a no ground truth answer. I could decide that we're going to divide by 10, or she's going to think she's going to divide by 8. So those two are techniques that machine learning can help you solve. But is machine learning able to deal with all the data outside? Well, kind of not, because when it comes to image processing, when it comes to text recognition, so voice recognition, well, the classical machine learning is not going to answer your questions. And then we move into deep learning. Deep learning is not really a new field of studies. It's been there since 1940s. But what is changing now is that we have access to more compute power. We are training our models no more on CPUs, but we use GPUs, which allows us to run the algorithms much faster and being able to train more bigger data sets. In this case, it's how we discretize an image in order to recognize the different patterns that the images has in. But I will introduce you to this topic with a specific example. So let's suppose that my objective is to estimate if this is a 2, so which digit is actually putting inside. And the idea is that I'm going to take a picture of the number, put it inside of my black box, and receiving a probability of this being a 2 or any one other digits. How does it work? So pretty much, I will have a set of inputs and a set of outputs. The set of inputs will be, in this case, is an image of 16 pixels times 16 pixels, so 256 possible inputs, which are labeled x1, x2, until the last one. And I will say that if there is an ink present, then I will say it's 1. If there's no ink, I will say it is 0. And then I will do the output. So I'm moving from a field that has 256 features into a vector of 10 possibilities. And I will estimate the probability of this picture being a specific digit. And in this case, it's digit number 2. From a mathematical perspective, why is it complex, why is it deep, and which kind of algorithms works? So deep neural networks is the main topic behind deep learning. There are many different ways of creating and constructing neural networks. Deep means that we are including many other layers. So as more other layers as you will add inside of your algorithms, as more deep it will be. And it's computationally expensive because we're dealing with multi-dimensions. So the function, which actually is going to estimate our neural network, moves from R256 to R10. And that's just using a simple image, a 16 by 16 pixel. And image recognition is now well done. There are many open source algorithms that you can work on. What is now the new challenge in the image is actually object detections. So giving an image, I want the machine to recognize what is inside. But both machine learning and deep learning are actually applied within the field and in the business. I will cover both the banking and the research, and then Rima will conclude with travel and retail. So what we're doing in the banking, I pretty much cover the Europe countries, and this is what I'm seeing most common within the banking field. So from a machine learning perspective, risk management and fraud analysis is very key. What the the bank is doing is very similar to the retail. So I want to identify my good customers, those that will pay back my loan, the loan that I give into them, those that are going to send their salary within the bank, and they're going to invest, and tailor like also personalizations offers within the bank. Then for fraud analysis, it's very interesting. Is pretty much a classification problem, almost a near real-time classification problem, because every time we do a transactions, behind there is an algorithm that authorizes your transaction based on specific like data that the POS with the banking is sharing. And in this case, with a likelihood, it's going to say yes, approve the transaction or reject the transactions. Then we do, obviously, forecasting and stock exchange and portfolio optimizations. That's been done both with machine learning and deep learning. But what's really interesting, and I work in this with a bank in the Netherlands, is that they have a bot framework, which is actually artificial intelligence, and they want these virtual assistants to act in a way it was like human being. And in that case, we are using a neural network that is based on processing natural language. And it's very interesting how to see how the bot is learning based also on how the customer is asking different questions and how it's engaging with the people. The goal of the artificial intelligence is to make the machine as more similar to us as possible. And it's very nice field of research, but it's also a great applications for the industry outside. Then within the coverage of the education sector, I'm working now in those three main topics, which is audio detections, metagenomics for precision medicine, and object detections. For the audio analysis, it's actually with the biomaritime, and they want to, they're listening to the wheel sounds, identify male and female, how they move within the oceans. That's going to tell them how the migration is affected by the global changes of the climate, which is very interesting from a biomaritime biological perspective. The metagenomics analysis is actually been used to study the DNA for precision medicine. This morning we had big talks about it, and as you now know, it's very important. It's actually one of the fields where big data is really present. We are working closely with the FDA, and for just this project, we have more than 100 terabytes of data. And the last one is pretty much the object detections. So as I mentioned before, into the deep learning, object recognition within an image is something that we now can solve. But object detection is something that is more complex. It requires both deep learning and machine learning techniques together. And when you're dealing with images that are scale of grays and where boundaries are not well defined, the algorithm gets even more complex. So this research customer is convoluting like both physicians, mathematicians, statisticians, and computer science to work together. What I've been seeing from my experience, and I hope I can transmit this to you, is that it's really a team effort. I'm a mathematician, but obviously I don't know everything that medicine does, and I really work closer to the team, and also with the computer science. Another good topic is all of the projects I did were in the cloud. Not because it's Microsoft per se, but because it allows you to spin up machines and have compute patterns in no time. So you don't have to go to procurement, get an hardware, and install everything. Everything is already there, and you can start to play and find your analytics in zero time. But obviously, we have more examples, and I pass to Rima to continue to the travel and aviation.
Thank you. So tapping into the travel and aviation industry, I have been extensively working with different airlines, airports, and travel industry in the Gulf specifically to untap insights from their data and use extensively machine learning in that area. Okay, so data-driven travel. One of the key areas that they're trying to tap over these days is profile their customers, try to understand customer behaviors from social media, from previous purchases of their ticketing. For example, if you have browsed their website, for example, a couple of days ago, and you showed interest, for example, in traveling to exotic islands or traveling to the Caribbean, what is the probability using machine learning if they can address to you a customized offer going to Cuba, for example, or Costa Rica and sending it directly to you or to her. So profiling customers and trying to understand customer behaviors based on social media trends, based on website trends, how do you interact with their website, and personalization is key in the travel industry. Another sector in travel and aviation is basically operations. So one of the key areas leveraging Internet of Things and data science in specific is combining the two together to maximize their operations and being proactive in their operations rather than being reactive. We have been touched base before in the previous of panelists and speaks before about the importance of IoT and the predictive maintenance of airplanes. What we have done across in various airlines, we have been gathering data, telemetry data actually from the actual airplanes, and through historical data we are able to tap and predict when will those parts they might actually fail, so that we can raise flags that those might probably fail. Please, let's do proactive maintenance. And by doing this proactive maintenance, airlines and hence airports will be cost saving in two areas. One, they will be cost saving. Rather, they will be proactively, let's say, maintaining that rather than repairing the piece itself, and thus they save cost. And two, they save cost of delays, in the sense that whenever an airplane lands in an airport and there is a sudden fault in one of its parts, then that will cause delays across. And by doing that, they will minimize delays and they will optimize their operations accordingly. And this has been leveraged a lot in the region and worldwide. We're partnering with airlines, we're partnering with engines, with engines who manufacture that in order to cater for such kind of things. And this is basically an example where we were actually reading the black box data in that engine. And we are able to tag the flights, and we are able to tag the planes themselves and where they are specifically, and raise a flag that, hey, you need a proactive maintenance directly, because based on historical data, those faults might cause a direct fault in your engine or a direct fault in any part. And a lot of aviation partners are using that nowadays. Questions? Go on. All good? Great. Okay. The next one, which I was deeply involved in flight operations, is what we call gate planning. Now, this is one of the most interesting topics that I had no idea it was a science by itself, but apparently assigning a plane to a gate is not random at all at the airport. Rather, it's a science by itself. Assigning a plane to a gate is not that let's assign it to the first nearest gate that is available. On the contrary, assigning it to the gate, it means compatibility with that gate. It means solving the problem of where shall I park that airplane, in the sense that those connecting passengers in that airplane will walk the minimal distance to get to the next connecting flight. And our team of data scientists have been solving this algorithm across with various airlines and airports in order to solve that. Apparently, this was random before, and it was based on intuition, and intuition was working good until we came into the picture and we were helping them to automate that process and optimize their operations. And operations were really, really optimized this way, in the sense that connectivity and flight delays were minimized big time in that case scenario. Apart from talking about how can we predict flight delays based on weather conditions, based on wind condition, based on social media events that are happening across the world, for example, if there is a strike in Charles de Gaulle Airport, operations will have to cater for how can they manage their operations and ground fleet in order to cater for that, let's say, strike across. So different kind of machine learning algorithms that were applied across this aviation industry, that is really, really cool. And hence, machine learning and a cool industry knowledge can really make magic. Science, actually, not magic. Okay. The last but not least is that I want to tap into data science in retail in specific. This is the dearest to my heart because it's really fun to work with, and you have unlimited scenarios to work with. What we have been doing. Well, first of all, let's talk about data science in retail. Retailers nowadays are expected to target people in a customized way, in a personalized way, in a targeted way. I do not accept anymore any retailer that I log into online, for example, or I go to the shops and register to the loyalty cards to send me irrelevant information. For example, to send me information that there's discount on clothes for kids, whereas I don't have kids. This is irrelevant information, and probably I might churn out from them. However, I do appreciate if I log into their website, giving my credentials and knowing that I'm a customer, that I was very, very interested the day before with a new phone that they have released. Probably the next day, they might send me a specialized, personalized offer that, hey, if you go and grab it online today, you will have a 20% discount. That I would appreciate, and this is how the retail industry is shaping the new personalization and is shaping the new, let's say, society. So given that, personalization is the key operational in data science across that, and it's shaping the world in a different way in personalization in specific. One case scenario that I have been working with across the Gulf is the mall connectivity, or what we call the connected shopping mall. So what we have done with that mall is that, first of all, the mall wanted to know what is the mall footprint, in the sense that based on Wi-Fi connectivity and based on beacons inside the mall, once you walk in and you connect to that mall, we can actually specify not you as a person, where are you going, but based on general telemetry that has been sent from those hotspots, we can know what are the hot paths inside this mall, we can identify what are those hot areas, we can identify what are the peak hours in the mall, we can eventually predict from just this simple information from telemetry what are the peak hours, when is going to be a crowded place, and thus they can mobilize in supply chain, they can mobilize in inventory management, restaurants in the mall basically can cater for that, and they can actually shape that accordingly, where they can know what are the peak hours so that they can do that. The next step after that, once you know the path and the telemetry, you can actually know, based on historical data and based on the mobile app, if you have the mall app, I can know, oh, yesterday you have logged into our website, and you have, let's say, viewed this booth or this mobile phone. How about if you walk in the next day in the mall, and while logging in into your application, I know that this is you, and how about I give you a direct personalized offer at the right time that, hey, if you walk into that shop, maybe if you go in, we'll have a 20% discount if you go and grab that phone, for example, or that booth or so ever. So this is a scenario that we have been working on in the UAE with one of the biggest malls around. And basically, we have analyzed the data, the peak hours, what are the peak hours. We have projected the mall map and what are the hotspot areas. And ironically, once they knew what are the hotspot footprints, the rent of those areas have gone up, right? So they want to maximize the profit accordingly. And then we have forecasted what are the peak hours at the end of the day, and forecasted in the future when are the busiest peak hours based on historical data and seasonality, and then you're targeting them with those personalized mobile campaigns. So we analyzed, predicted, and personalized. One last thing to say is that with data science, in every industry, really, you can do a lot of things. So had it been in retail, manufacturing, services, health, even government, really the sky is your limit. All what you need to know is some industry expertise, data, and of course, science. And that's it. Thank you.
Thank you so much. That has been so inspiring, and I learned a lot. I feel like I'm monitored all the time now. Don't you feel the same? I want to stop using my phone now. I'm not going to do anything.
We can discuss data privacy if you like.
And also Dr. Ibrahim. Sorry.
We can discuss data privacy if you like.
I'd like to ask the audience if you have any questions for our speakers. I'd like to ask the audience if you have any questions for our speakers.
There is a question.
You have a question here?
Hello.
Would you kindly...
Yeah. So my question is about the recommendation system for Dr. Rida. And I was wondering, when you were explaining this system of recommendations, that how can you control that the system doesn't become its own self-fulfilling prophecy thing, whereby basically you're recommending things and then people are viewing these videos based on your recommendations, so your data becomes skewed because you're just analyzing what you're feeding them. Does this make sense? Okay, so basically my thought is that you are the platform where you're collecting your data is the same platform where you are feeding your data. So you're recommending films, and your viewers are watching these films based on your recommendations, and then you're collecting the data of what they're watching to give them more recommendations. So the whole thing becomes totally in your hands, and then they have no free choice as to what they're watching. And you're using this data to continue this circle.
Yeah, I mean, this is a very, a question actually that I asked myself when I built recommendation engine. So I was asking myself whether these people would naturally want to view the things, or am I influencing this choice by putting these things in front of them? Like, it also happened to me that sometimes naturally I would be interested in seeing something and it would be recommended for me. So I would say, oh, I wanted to see this, that's nice that I have it recommended. Sometimes things come to me out of the blue and I see them and I feel, oh, that's interesting. Let's listen to the next talk by this person or next song by the singer. Yeah, I mean, we're at the same time being influenced by what people have seen, and not only by you as like a user, but also by all users, because as I said, what is recommended to you is influenced also by what others are seeing, so it's based on the similarity between you and others. But at the same time, we are influencing you in what you are seeing. Yeah, it's in some way, it's some kind of manipulation. There is some kind of manipulation in this. I agree with you. But yeah, how to do it better or how to change it? I mean, as long as it works, as long as it generates some interest, as long as it generates interactions, more viewership, maybe it opens the eye of someone to something new, I think it's working, and I think it's still, even if it's in some way manipulation, it's still ethical. Yeah?
Keep it with you.
Yeah. We have a question here. Thank you.
Over there.
Sorry, I have the mic. Sorry. Here.
Oh.
Yeah.
I'll come back to you. Sorry. Yes?
My question is to Dr. Ibrahim as well. Your 12 fields did not include the rating, and nowhere do your users actually rate the movies. Yeah. So I'm a little vague on how you came up with the rating system so that you can recommend.
Absolutely. Actually, like in some kinds of viewership, for instance, if you go to Netflix, you have the option of rating the films that you have viewed. But in the data that I had here, I had no ratings. So this like IMDb data, I didn't have it. But we produced our own rating, and I think that these ratings are more reflective of the real behavior of the people and real impressions of the user. So they are basically based on the frequency of viewership. So let's say that, I don't know, you have seen How I Met Your Mother like 4 times during one week, and the maximum user in our data set has seen this film for like 8 times, then your rating will be 0.5. You see? So in this sense. But it's not as simple as this. It can also include have you seen all the episode or have you seen a part of it? And this is just like one way of doing the rating. I mean, there are like many ways for building this rating metrics or user item metrics, which is very like important metrics and recommendations. You can also look at the search data. For instance, what have people searched for, and include this in your rating. What they have clicked on but they have not viewed. And you can give different weightings for all the things. You can also build different matrices and do different like testings and decide which matrix is the most efficient to use for building your recommender system.
We have a question here, please. Yes, you have the mic.
Hi, yes. Well, first of all, thank you very much, because it was really interesting. I thought it was fascinating to see in a very practical way how you apply data science and how you dive into your respective topics. Now, I'm not a woman and I'm not a data scientist. I run a business a business that's increasingly depending on having accurate data and gathering the data, organizing it, and then making decisions based on that data. So we're based in Beirut, and one of the things we're struggling the most is to recruit the right people, to recruit data scientists.
Mm-hmm.
So that's actually why I came here in the first place. My question for you would be, how did you get to become a data scientist?
Mm-hmm.
Like what you showed us today, or just now, is it, I mean, I'm guessing the answer would be no, but is it, did you always do that, or was it a gradual process, where you groomed into becoming a data scientist?
Mm-hmm.
What was the process to get there? And how could we get more people trained this way? And how, as a company, could we hire fresh grads and groom them into becoming a successful data scientist as you are?
Okay. So I'm going to start, and Daniela can give you further information around that. So how we have built that is actually teaming up in teams, right? So you have the subject matter expert, you have the data analyst, you have the data scientist at the end of the day, and building this team and building the industry expertise at the end of the day, all those combinations together can lead to a proper, let's say, output that you need. There is no one size fits all data scientists. You might have some data scientists that are good in, let's say, in one industry rather than the other, but you don't have one data scientist that is good in everything. So it's gradual as you go. You have to build your team. It's a whole new science that is over there. So analytics and asking the right questions is key. So your data analyst or your data specialist, your data scientist should be data literate, and to ask the right questions and to really know on top of hand of what are those industry specific problems or goals that they need to solve. So it's a bit of a combination of everything, and it grows as you go. So you don't have one data scientist that fits all, absolutely.
From my experience, I studied math, and I was already coding in R, and I started with health data because that was the most request at the point in time. And now I'm moving into different fields. I worked for Vodafone for almost 5 years, so I did telco. So my SME experience is actually in telecommunication, mostly. But I think that if you have passion for math or statistics and you somehow like to code, I mean, you're not going to be like maybe the best code, but you can write something, and then you have the passion to learn, because anyway, like machine learning or algorithms will never stop. Now we are in the phasing of deep learning, there will come AI, so you always need to have the willingness to open the book again, study, and I think that if that's there, you can do it easily. You need to invest in people in the long term. It's not going to be like open the box, the person is ready. But if you train them, if you make them love what they're doing, then they will go into. And what I've been seeing, at least in Europe, is that people are insourcing data scientists rather than using consultants because they have the knowledge of the business and how the algorithm works. So that's what makes your differentiators in terms of factors competing to the other people.
One more thing that I need to add, that technology today does embrace data scientists with minimum knowledge. I mean, there are, with technologies, for example, like Microsoft or others, we have out-of-the-box machine learning algorithms ready to use. You just need to ask the right question, use the right algorithm, and have some data analytics skills, and you can actually do machine learning. So they don't need to be PhD students. Yes, sometimes, you have to reshape the code and deep dive into it, but we have out-of-the-box tools that you can start with and use at the end of the day. And then you can use R and Python and deep dive into all those questions.
Before taking the last question, I just would like also Dr. Masoud to elaborate a little bit from an academic perspective and someone who works in big data. What is the role that we can play and you are playing particularly at Melbourne University to encourage more women to take on this tough and challenging and non-typical kind of career path?
Actually, yes, that's a very relevant question for finance industries dominated by male. So I have a research center, and in my research center I'm building a large database. I recruit women, and I try to encourage them to work into developing data and answering important and relevant questions to the industry. Additionally, when I go like to classes in teaching at teaching level for MBA students, I always notice MBA students, this is what we teach at Melbourne Business School, they tend to choose like maybe consulting, strategy development, and they avoid to the finance discipline. So I try from the first stage when they join the school to speak to them about finance and to encourage them to consider taking this field. Recently, I succeeded actually converging people to the finance industry and encourage them to tap this field. So additionally, what I did lately, I established a network where I run annual conferences, and the focus of my conference is women in finance. So what we noticed in Australia and in North America as well, most of the time conference organized by male, and they tend to ignore inviting women as a keynote speakers. So what we did in our conference, we developed a conference where we have the scientific committee all female in finance, and the keynote speakers actually also in finance. And this year, for example, I just actually finished the conference, and then I flew right away to Lebanon. We organized the conference during the tennis open, and we take our delegate, female and male, to watch the women final in the tennis. So in other words, we champion of women. We encourage women to succeed in everything, even in tennis. And I encourage you all actually to help women to have proper representation. Here I'm not biased just to women. I want reasonable representation. If you go to classrooms at entry level like commerce, like for example, we have almost 50% women. How come when we go to a higher level, we see much less representation? In the finance field, we have less than 10% in female. Why this percentage drops when women progress in this career? That means our voice need to be heard, and we need to be proactive and do something different.
Thank you, Dr. Masoud. I'm going to take the last question and limit the response to as short as possible. Yes, please.
Do you think that IoT will dismantle the social media platforms? Since Facebook wants to know what things you want to buy, while IoT goes directly to the things. Okay, so do you think it will dismantle the power of Facebook and other social media platforms?
Who would like to tackle this question?
I think they go hand in hand, basically. Social media will always be there to check the social behavior of things, and IoT will always be there to check the performance of things. So combining those together will always come hand in hand, from what I see of the future.
Well, you know that in the refrigerator at home, okay, if you don't have, for example, bread, okay, the IoT will know that you don't have bread, okay. It's not only about machine
but
generators.
Maybe you don't want bread, right?
Maybe, but it will know that you don't have, you know. Maybe you want pasta.
It's different. Yeah? I get your point, but I still do believe that they come hand in hand because social behavior and things behavior will not take the other. They will still go hand in hand, at least for now. We don't know about the future.
Thank you so much for all the questions, and a big thank you for our panelists today.
Thank you.
Thank you for having us.
I would like to invite Dr. Lama Moussaoui to conclude this, and thank you for everything.
It is now almost 8 a.m. In California at Stanford University. The Stanford WiDS conference is happening now at Stanford, so you can watch it online. We also encourage you to continue tweet about the event. And finally, as the AUB Stanford WiDS ambassadors, Fida and I want you to mark your calendar for the second AUB Stanford Women in Data Science conference that will take place on February 1, 2018. Thank you everyone for making this event a huge success. Thank you.